All right. Good morning, good afternoon, good evening, no matter where you're at. Thank you so much for joining us today. My name is Matthew Bonnick, and this is CDK Day 2022. We are happy to have you. We're going to jump right into it, but beforehand, there are going to be four little housekeeping things that we're going to get started with. First off, we're going to have multiple tracks today. If you would like to join in any of those other tracks, then you can head over to the CDK Day YouTube channel here, and you'll see tracks 2 and 3. Of course, we're on track 1 right now. Number 2, we've got Slack channels available for you over at the cdk.dev website. You'll find our Slack channel there, and we've got 3 channels: CDK Day Track 1, CDK Day Track 2, and Track 3. During any of the talks, you can join into those channels, have a conversation with everybody, and sort of talk about what's being presented and discussed, and we'd love for you to join in there. Number 3 is, because this is a community event, we do have a code of conduct. Please check it out on cdkday.com/COC. The TLDR, just be kind to each other and we'll all get along great. And number 4, once again this year, we have Western Interpreting Network doing our ASL translation today for us. We are super excited to have them back. They were fantastic last year, and we couldn't be happier to have them back. So for everybody who might be hard of hearing, hopefully this will work out well for you. All right, that's it for the housekeeping. We will go right into it. Now, you may know him as the creator of CDK-defined is also the first ever award winner of the AWS Go Build It award. He is the co-author of the CDK book, and he is the creator of CDK Day. He's a man who needs no introduction whatsoever, and he's a really small guy. My friend, Matt Coulter. Welcome, Matt.
Thank you, and thank you for such an awesome introduction. So, listen, everybody, I just wanted to take a maximum of 90 seconds here, and I just really wanted to impress on you the scale of CDK Day this year, because every year we do this, and every year it's a community organized event, but it gets bigger and bigger. So this year we actually had 36 sessions that we started with. Now, unfortunately, a couple have dropped out at the last minute if you're wondering about agenda changes. But those 36 sessions, if you look at them, this this map of the globe, all these pins are either a speaker or somebody on the organizing team. And all of these people are doing this for free from their own time just to help everyone else have fun and learn about CDK. And that is what I love about CDK Day. The next thing I wanted to show you is you're not alone in watching CDK Day. There's thousands of people who have signed up just for tickets. Like, anybody can watch this on YouTube, so you don't need a ticket. But going through the session system, I can see where you're all from. And look at where our audience is. Again, we don't have a marketing team on this. This is just word of mouth, audience spread. I think that's incredible. So some of you, I guess, introduce yourselves on the chat and where you're from, because I think that would be awesome. And then lastly, there's a large team comes together to pull this in place. So there's a lot more than the people you see on screen, even though you'll see a lot of them on screen. So these are all the people that were in the committee that came together to make CDK Day happen. And they're all listed on cdkday.com if you scroll down to the committee. But I just wanted to make sure they all got a couple of seconds on screen, just so that everybody knew that I'm so appreciative of them all giving up their time to do this. And with that, I guess, Matthew, I can hand you back to the regular show.
Perfect. Thank you, Matt. Really appreciate it. Thanks again for putting this together. And we will see you probably next year.
Hopefully so.
Thanks, Matt. All right. So we're going to move right on into our keynote. We've got a very special guest with us today. I'm going to hopefully get this name right. We'll see. Rico
Sure.
Huber's. Did I get that right?
Pretty close.
Well, you know, I'm
I'm gonna.
American. We don't get names right at all for
I
foreign
know
languages.
it's a very hard sound. I know.
Well, thank you very much for joining us today. I'll let you get right to it and have at it. Thank you, sir.
Thank you. Thank you. Thanks to the organizing committee. Thanks everyone watching. Thank you all so much for coming for another installment of CDK Day. So great to see everybody come together and be so dedicated to what we are all convinced is like the future of infrastructure as code. Or not even just infrastructure as code, I want to say just cloud development in general. I called this talk the State of the CDK because I want to have a look at where we're at, what we've been up to over the past year, and where the CDK team's attention is currently focused for the next year. I want to start by looking back a little, and if I have to describe where we're at right now, the period we're in and the period we're going into, I want to say it's like the period of maturity. And maturity is exciting, right? We're finally grown-ups. We're ready for real work. We're ready for production, as we all know. There are also parts to it that are not so exciting. Many more people rely on us now. There are more demands. There's demands for stability. And with that comes some hard choices. And I will get into that more later on. One thing it definitely doesn't mean is that we're done or even close to done. We have so many more ideas of stuff that we want to do for you, that we want to work on. In fact, many more ideas than we have capacity to work on. So we'll have to be a little selective. And I'll get more into that as well. But let's start by looking at the last year. So since the last CDK Day, there have been about 55, I think a little more by now, releases. That's just about one every week. And over that period, we've been able to merge over 2,500 PRs. And if you look at the distribution, it's pretty amazing. It's about a third of that, actually, more our community contributions. So that means there have been changes proposed and implemented by you. And I want to say that's awesome. We literally would not be able to do this without you. We wouldn't be where we are today. We wouldn't have the capabilities if it weren't for all you amazing people. So thank you so much for that. And with that said, I want to go into some announcements over the work we've been doing over the last year. And the big one is, of course, AWS CDK version 2. It was actually announced here last year at CDK Day. We re-GA'd it at reInvent. And the big advantages of it are it's only one dependency now. We combined all the code together into one big library. So it's much more convenient to work with. You don't, every time you want to add a new service, you don't need to add new packages to your project. You only add this one dependency, which is the CDK. And then you're done. And we split off the experimental modules because we do want to still have room to experiment because we're building abstractions with human effort. And sometimes we get it wrong. And so we need that room to experiment. But we split that off so that it's very clear the parts that may change. And now in the core library, we can give a good guarantee of stability. And that makes it possible, that is a requirement, that makes it possible for having multiple construct libraries in your application that all depend on CDK, and you can upgrade them independently. You don't have to upgrade them all together anymore. So really, this is the better experience for using CDK, and I would recommend everybody to upgrade right now. It is definitely the experience. So that was the carrot. There is also a stick. We're going to be putting V1 in maintenance mode starting next month. And what that means is it's only going to get security updates and automatic CloudFormation spec updates, but manual development effort like L2 features and bugs aren't going to happen anymore over there. They will focus those on V2. All right, so please all join us in V2 land. Upgrade your projects. If you have applications or libraries, please upgrade them. Most of the API is the same, except we removed the deprecated APIs. But it's a couple to upgrade. It's a couple string replaces and maybe a feature flag here or there. And we have a good topic in the developer guide that goes in exactly to how that works. So please all upgrade and let's all go into the library that allows for ecosystem growth. Next up, another big one, Golang support in JSAI. So this is still the most upvoted issue on our issue tracker. It's amazing. 1,000 people said they'd really love Go support. So I hope they're all very happy because we're finally ready for GA. We also announced this last year. We were working on it. We had a release candidate on reInvent, and today it's finally GA. So you can start using our products. AWS CDK is published in Go. CDKs, obviously, is published in Go. So you can start using those today. And if you are publishing a construct library and you think your customers would enjoy Golang support, You can just add a flag to JSAI and you will have Golang support going forward. For example, if you're working in the Kubernetes ecosystem, right? The Kubernetes ecosystem, they enjoy working in Go because it's also the language Kubernetes itself is written in. Speaking of Kubernetes, there is also CDKs and there's also announcements here, right? CDK's v2 now depends on the same constructs library that AWS CDK v2 and CDKtf depend on. So with CDK's v2, you'll be able to use all those constructs together in the same application and combine them and synth them independently and then deploy, for example, to your CDKtf constructs to EKS. But much more interesting is the release candidate of CDK+. And if you're not familiar with CDK+, it's an L2 library for CDKs, right? So it's very comparable to the AWS construct library is for AWS CDK. It has the same kind of intent-based abstractions that make development easier, right? So for example, we recently added scheduling and network policy support. So with a couple of lines of code, you can say, give me this deployment, spread it over hosts, and make sure it's co-located with the database that I want to be able to talk to. And the CDK's library is going to make sure of the details there. So it's going to generate the tags in your manifest, and it's going to generate the affinity and anti-affinity clauses to make this a proper production quality deployment. So we feel this is kind of rounding out the CDK stack very well. And we're going to let this, so it's a release candidate. We're going to let this bake for a while. The goal is to have it GA later this year. We're always collecting community feedback. So if you feel like anything's missing or you have other improvements to make or suggestions, we're always listening. Come to our GitHub and let us know. And other than that, check it out. The next one is not really an announcement, but it's more of a reminder, right? So this is Construct Hub, was also announced last year. And it's a website that indexes and hosts documentation for all construct libraries, for all CDKs that are being published. And it has over 1,000 already, right? So if you're in need of a construct library, if you want to add something to your project, if you maybe need a serverless website or a cron job with monitoring and alarming, you might want to search here first before you start building, because it might be that someone already built it and you can save yourself a whole bunch of time by just taking the construct from someone else and using that. And conversely, if you would like to publish yourself, just make sure your project is built with JSAI and add a couple of keywords to the package metadata. And then once it's published, it's automatically going to show up here. In fact, if you run this Projen command line, it's going to give you a new project that automatically will show up on Construct Hub as soon as it's published. So two things are interesting about Construct Hub. So first of all, it is open source, as is everything we do. And it's itself published as a construct, which means you can take it and just put it into your CDK application and deploy that, and you will have your own private copy of Construct Hub. So if your company has their own collection of construct libraries, and you would like to have better visibility and discoverability and documentation hosting on those, right? You can just take Construct Hub, hook it up to your own artifact repository, like maybe Code Artifact, right? And then run it on your own package catalog. And we know of one customer doing this already. And second, it is also just an example of like a real life complex application being built with CDK, right? Being built and developed and distributed and deployed using CDK. So if you ever need inspiration on how to do something, you can look at what we do and take inspiration from that. And then finally, I want to touch on something that's been happening, and it's not something we've personally done, but something we're very excited about that it has happened at all, and that is that provider choice is arriving for AWS CDK. Right? We've always intended for CDK apps to be the important artifact where you describe your application layout and your runtime code and everything. And that CloudFormation was, more to be considered an implementation detail of how this finally gets into the cloud. But we've been a bit preoccupied with other things before, we could actually make that happen. But we are very happy to see that people at Terraform and Pulumi, and also our own CDK's team, have taken up that challenge. So it's now possible to take your AWS CDK constructs and deploy them using other provisioning mechanisms. And I know they're on the schedule. We will hear a lot more about that today. So I won't say too much about it. But it's exciting to see that this construct programming model is getting so much leverage, right? That the investment is paying off, that users get a choice of how to deploy their applications, because everybody wins, right? If we have more choice. So I want to thank everybody who worked hard to make this happen. I think that was about it for the last year, and everybody's always very interested in what the future brings, right? And I don't know. Best I can do is tell you about thoughts we're having, things we're prioritizing, right? And even priorities might change, right? What I'm going to tell you is like things we're thinking about, things I'm thinking about. It's actually not a roadmap or even a plan or a promise, and they may change. So with that said, take what I'm about to say for what it's worth. But this is what's currently on my mind. With CDK, we have a couple challenges, like 3 big challenges, I think. And that is, the first one is CDK tries to be very generic, but it also tries to help you by being an abstraction. And any abstraction hides details and makes choices, right? And that is in various aspects. That's in our deployment mechanism, as we already talked about. That might be in our bootstrap resources. That might be in the naming we choose. That might be in how we handle permissions. That's even the fact that we are a client-side tool that requires an IDE and a project and everything at all. And CDK, we all know CDK works great, right? If it fits, it works wonders. If you agree with the choices we've made, or if you don't care about the choices we've made, CDK can work wonders. But there are environments where CDK doesn't quite fit yet, where they disagree with our choices and need to see them made differently. And we really believe CDK is the future, right? And that we can extend this programming model. But we need to figure out how, right? We need to make sure we can make CDK work for everybody, and without losing the convenience that makes it great today, and without becoming like an endless list of configuration flags. So that's a challenge. We have some thoughts of how to tackle that. I'll get into some, but there's a lot of work to be done there. Second of all, CDK code contains a lot of information. A lot of information we could be using in various places to help you with various tasks, right? Maybe we could help you with debugging, for example. We know what's in your application. We know things that might go wrong if you combine a load balancer with a Route 53 record, right? We could help you with operating your application. We could help you with cost analysis and prediction. We could help you do some security analysis. All of this is possible, but we need to figure out how to do it and where to invest our time. There's so much potential, but it's untapped still, right? We stop at deployment and that's about it. And that's unfortunate, right? We need to do more here. And the third one that's currently very, very high on my mind is the development of CDK itself. There's so much happening all the time. We all know AWS. AWS is releasing new features all the time in all teams. And at the same time, people are proposing improvements to CDK or request changes. We have our ideas of how to make you more productive and things we could be adding. And we need to find a way to keep that development sustainable, right? It's how do we keep ourselves from becoming a bottleneck? Various things we could be doing as well there. I'm going to go into some later. But these are like 3 big challenges I think we have ahead of us. So let's have a look at the details of how we're going to deal with those. So the first one is a project we call CDK Launchpads. So it's CDK for opinionated environments where CDK doesn't fit very well. I've called it controlled environments. So last year we rolled out CDK pipelines, which is our CI/CD solution for deploying CDK applications with a minimum of fuss to any account and region, and it works great. And it's pretty, it's working pretty well. About 1 in 3 accounts are using CDK pipelines today, which is fantastic to see. But we noticed that in larger environments, and let's call it control environments, it doesn't quite fit yet, right? And these are environments in which there's typically 2 groups of people. You have the application builders who want to use CDK to go fast, and then there will be a centralized IT team who also want application builders to go fast, but they also need certain guarantees, typically to hit compliance requirements, to make sure certain things can or cannot must happen or cannot happen. And in those environments, CDK was not fitting quite well, right? And Launchpads is our the umbrella term for what we hope to address with that. We have a plan for this, and it's written up in RFC 419. And RFC quite literally stands for request for comment. And it means what it says. We have a repository of these, in case you're not aware. We have a repository for these. The link is there at the bottom of the screen. And we wrote up our plans in public, as we do everything in public. We wrote our plans and our designs, and please read them, especially if this applies to you or you're interested. Read them and give us feedback. Tell us what you think will or will not work. Tell us your requirements. This project really lives and breathes with the participation of the community. And at the same time, the RFC process is not just for us, right? It's also for you. If you have like a proposal for a change to CDK or a big feature, we'd love it if you would write up an RFC and tell us about the use case you'll be addressing, the user it's going to be intended for, and the problem you're solving, and how you're going to do that. This is what we do, and we hope you give us comments, and the reverse also works. So RFC 419, please let us know how our plans work. In the sense of what are we going to do with CDK construct information after deployment, we call this the post-deployment experience. It's like the first lifecycle area we're thinking of tackling, is to help the operator. Right? We want to help you operate after having written and deployed your CDK application. We want to help you operate it. So CDK is great for authoring, right? As we all know. But at deployment time, currently, it kind of folds out into a giant flat list of resources, and they'll spread out all across the AWS console. And wouldn't it be great if we could have like a single page with a single entry point to your application where it shows the resources in there and their relationships. It shows monitoring, it shows logs, and all that kind of information, right? It may be like management operations you're likely to do. Fortunately, something like this exists already in AWS, and it's called Application Manager. And you can find them in the AWS Systems Manager console. And they have a dashboard for a complete application experience inside AWS. So definitely check them out. And we're talking to them to figure out how it makes, what would make most sense for CDK applications, how we should integrate with them, and what kind of information makes sense to show to users. But again, I would implore you, request for comments. We have an RFC for this. This one is not a proposal yet. It's just an issue with where we can discuss, right? It's RFC 437 in the same repository that I showed in the previous slide, AWS CDK RFCs. You can Google for it. Please let us know what you want from this experience, right? What would your ideal experience look like? Is there anything that frustrates you? Is there anything we can help you with? We have some ideas, but we need to hear from you to make sure we get it right. So again, please all check this out. And then finally, development, right? As I said at the beginning, about 1/3 of all our contributions come from the community. And I want to thank everybody who took time out of their day to file issues or to even make pull requests, even one-liners, even documentation improvements. Everything's appreciated and everything's great. But our backlog seems to be growing over time, right? And it seems we're becoming a bottleneck, and that's the last thing we want. We don't want to be a bottleneck, right? We want to see all that amazing creativity and energy. We want to see that go out in the world. And currently it's all going through us. And that is, that's not a great experience, or not a great experience, but it's limiting for you, and it's frustrating for you and frustrating for us if we can't get to, your work. And there's some things we can and will be doing, right? First of all, when we finally are able to get rid of V1 and stop maintaining that, we'll be able to simplify our build a lot, because we are currently building V1 and V2 from the same code base, which makes it complex and take a long time. If we can get rid of that, it's going to improve our build times dramatically, all right? Which is going to improve your contribution experience, is going to improve our reviewing experience and context switching experience, and we're all going to be able to go a lot faster. So that's, again, an efficiency. We might look into code generation more than we are doing today, because that's going to scale better. We might also reach out to some people in the community to help us with reviewing PRs. But even if as we ramp up our own efficiency, we can't do everything, unfortunately, right? There will always be more energy and incoming work and initiatives than we are able to get to ourselves. We try to set an example for what we think a good development experience for the cloud would look like, right? What the magical right APIs and abstractions are to make you as efficient as possible. But we have to limit the work we take on at some point. So maybe the solution is we focus more on extension points in the future, like CLI plugins or the pluggability of the CLI, and have community come up with the features that go into those plugins to make users more efficient. And maybe new work in the construct library goes out into Construct Hub first, where it gets tested in the real world and used by a couple of users, and the kinks get ironed out. And then after it's been out for a while and proven, then we upstream it into the core library. Maybe something like that. These are my ideas currently, right? We don't have an RFC for this. I'm not saying this is the plan, but I do want to hear if you have thoughts on this, like thumbs up, thumbs down, alternatives. I do want to hear about it. Hit me up afterwards on Twitter or GitHub or Slack. Come talk to me. Or even better, and I apologize for this in advance. This is maybe not chic to do in a keynote, but I'd rather ask for permission later. If it seems fun to you to work on CDK full time, or and want to deal with these challenges, and you have solutions for them, we are actually, in fact, hiring. So if you're interested in that, also come find me afterwards on Twitter, GitHub, or Slack, or email. With that, there's nothing left for me to say than thanks again, everyone. There's so much amazing creativity and productivity from this community. We wouldn't be here today if it wasn't for you. We wouldn't have all the features. We wouldn't have the maturity. We're all in this together. And we all think we're on the right track for the future of cloud development. And it means so much to see everybody else so excited about the same thing. So thanks again to the CDK Day organizing committee, and enjoy the rest of your day.
All right, fantastic. Thank you, Rico. Really appreciate it. Regarding the hiring, do you have benefits that cover otters?
We can make arrangements, I'm sure.
Yes. Okay, fantastic. That is great. Well, again, thank you very much. I was going to ask you what's the best way for the community to engage with the CDK team, but it sounds like you've already hit that all up with going to the RFCs, which we provided a link. Also through, I assume, the issues page there on GitHub is always a good place to go to as well.
For sure.
So do that. And then, of course, we've got the CDK.dev Slack server, which you guys have always been very active in and responding to those things. So thank you very much. We really appreciate it, and we can't wait to see what the CDK brings this next year.
Thanks for all your work, Matt.
Yep. All right, so next up we've got a Mr. Lee Briggs and a David Flanagan from Pulumi. They are going to be discussing what Pulumi has been doing with the CDK and support for that. Welcome, guys. Thank you very much for coming today, and it is all yours.
All right, thank you very much. Can you hear me, Lee?
I certainly can. Can you hear me, David?
Yeah, we're all good. Awesome. So welcome to our session. Lee and I are here to talk about Pulumi and CDK Interopt. So we'll jump on to the next slide and we'll kick this thing off. First, I'll introduce myself. My name is David Flanagan. You may know me as raw code from across the internet, especially GitHub and Twitter, which is most of the internet. I'm a developer advocate at Pulumi. My job is to help people be successful with Pulumi and also do weird and wonderful things that are people within our company always go, what, why? But it's fun. I enjoy it. And I'm happy to share the stage with my colleague Lee today.
And thanks very much, David. I'm Lee. I'm a solutions engineer here at Pulumi by way of being a software engineer and also a developer advocate at some point. You may know me as the person who provisioned a Kubernetes cluster with Fortran a few weeks ago, if you saw that blog post. But my job here at Pulumi is just to make customers successful. And hopefully Interopt with CDK will be part of that process for you. So I'll pass back to David.
All right, thank you very much, Lee. So I'm going to give you a little bit about the history of Pulumi and the evolution of Pulumi, just in case you're not familiar. But Pulumi is a relatively new project in that it's only been public since 2019. So, we're talking around 3 years, although it was in stealth mode for a little bit before then. But Pulumi launched with cloud support for JavaScript, TypeScript, Go, and Python. And over the years, we've added new languages. We now support all of the .NET languages, all of the JVM languages, and recently we support YAML as well, trying to meet developers where they are and provide the interface that they need or want to work with. At the same time, we're also focusing on this concept of universal infrastructure as code. We really want developers to be able to use whatever tools they find fascinating, exciting, interesting, and experiment without really having to leave the Pulumi context. So we have things like CDK support, which we're going to show you today, but also multi-language components, allowing people to author a Pulumi component package in one language, but be consumed in any other supported language, which is very, very cool. We're also going to show a little bit of the automation API today. This allows you to embed the Pulumi engine into your own software, whether that be a CLI, whether that be a website, whether that be whatever you're doing. So very cool projects, and we can't wait to show you some of this today with regards to CDK. So we are going to talk about CDK Interopt, but before we do that, we're going to kickstart our demo because it does take a few minutes, and then we'll jump back to our slides. So I'm going to hand over quickly to Lee.
Thank you very much, David. I'm just going to switch over to my terminal here. So what we're going to do here is provision a Pulumi program with the traditional Pulumi mechanism using the Pulumi CLI. So what I've done here is authored a Pulumi program, and let's take a look at exactly what that might look like when you're embedding a CDK construct into the Pulumi program as well. So you can see here, we're just importing the AWS CDK lib. I know Rico just talked about the fact that all of these things are kind of in the same library now. So if you import AWS CDK lib, you're getting access to all these things inside your Pulumi program as well. You'll also notice here on line 6 that we're using the Pulumi AWS provider. Within these Pulumi CDK and Pulumi program interoperability, you can use any of the Pulumi providers. So you can use any cloud provider, you can use things like Datadog or Cloudflare, and you can use them all from the same Pulumi program. If I scroll down a little bit here, you can see I'm going to declare a few resources with the Pulumi AWS provider. And then the thing that most people here will be most interested in is that we can then also access the CDK construct from directly within this Pulumi program. So you can see I'm going to create an ECS cluster, an IAM role, a load balancer, all the things you would need for a Fargate application to run. And we're able to mix and match the two different ecosystems. So we're able to use the CDK construct and the Pulumi provider as well. What this means when you're actually running this is that if I run a Pulumi up using the Pulumi command line tool, and I'm going to add the yes flag here so that we don't have to wait for it. It's going to compile the TypeScript locally. You don't have to use any kind of server-side execution engine if you don't want. It's all going to happen locally. When we compile the CDK construct, we map every single resource in the CDK construct directly to a Pulumi resource. So this is going to go ahead and provision a bunch of AWS resources talking directly to the AWS Cloud Control API or the AWS API to create those resources. We no longer have to worry about any of that server-side execution. Now, David already talked about Pulumi's automation API. Because we have the capability of being able to run these programs locally, we can actually use Pulumi's automation API to choose how we execute these programs. So right now, I'm just using the Pulumi CLI, but some people are using the automation API, or some Pulumi customers are using the automation API to build their own workflows, completely independent of any CLI or kind of CI/CD pipeline. So you can see here, I've got a Pulumi automation API program. It's embedded in an Express.js web server. So you can see here, I've started an Express.js web server. I also have a lovely front end that our wonderful colleague Kimberly built for us. And we can take a look at what that looks like. And this is the interface that we're actually going to present to our downstream users. So I'm going to call this deployment CDK Day, and I'm going to choose an Nginx image. And then if we take a look at this actual instantiation, you can see very similar to what we just looked at. I'm importing the AWS CDK constructs, and then I'm creating a Pulumi component resource, which is Pulumi's reusable abstraction that's very similar to a construct. David already mentioned you can make these multi-language. And you can see I'm importing all these things here into a Pulumi component resource. But then I can actually embed this directly into an Express.js web server. So then that is what the front end allows me to access. So you can see I have a create handler and a list handler and a get handler and an update handler. So I can actually manipulate the infrastructure directly from within this Express.js web server. So let's take a look what that actually looks like. If I hit create site, and I come back to my console over here, you'll start to see in this top tmux window here, it's running a Pulumi program, provisioning an provisioning of an AWS CDK construct that's including all of the great things that constructs give you, like a best practice VPC, a network load balancer, all of those different things. And this is all less than 200 lines of code to create this reusable abstraction. I have about 250 lines of code. I have 164 lines for my Express.js web server, and I'm provisioning all these resources in just about 250 lines of code. So we're going to wait for that to finish. And while that's happening, I'm going to hand back over to David to talk a little bit about some of the other things in the Pulumi ecosystem that you can use while you are using the Pulumi engine and the CDK Interopt. David?
All right, thanks, Lee. You're a bold man using tmux on a demo. I'm trying to remember all those keyboard shortcuts. Anyway, while we wait for that demo to run through and we can take a look at just how it all worked, I want to talk about something I'm calling the Pulumi fulcrum. These are the parts of Pulumi that we want people within the CDK community to be able to leverage along with their CDK constructs. So hopefully you can see the value in bridging these two things together. The first one I want to talk about is native providers. Pulumi has the concept of a native provider for Amazon, Azure, and Google Cloud. Now, when we say native provider, we mean we are not bridging Terraform anymore. We're actually relying on the Cloud Control API and likewise for alternative clouds to pull down the schema for all of their APIs and generate SDKs. What's really nice about this is that we get same-day feature parity with all the cloud providers. For example, at reInvent in December last year, Amazon announced VPC IPAM, and same day we had that available in our AWS native provider. So there's a lot of value to bridging these two ecosystems. Not only that, we try to be full spectrum. We want to interrupt with as many things as possible. So yes, you can bridge Terraform providers if you want to. Now you can consume CDK constructs. If you need to go off the beaten path a little bit, we also have a concept of a dynamic provider. A dynamic provider means that you and your own userland code can write one function that allows you to speak to an API that doesn't have its own provider. Now that's just going to be the create function. Of course, you will eventually want to implement update and delete, but you can just write some TypeScript or Python code to go speak to an API and have it managed as a Pulumi resource, which is a really powerful concept. We also allow generating of APIs from open API specifications. We have first-class support for Helm, so we can actually work with all Helm charts that are available on the Artifact Hub. And also we integrate with the Azure Resource Manager. We've already talked and shown a little bit about the automation API, but there is also a lot of power and flexibility in being able to embed the Pulumi engine into your own application. You don't have to ask your developers to install the Pulumi CLI. You don't have to ask them to install anything except maybe your custom bespoke CLI, which could be my company, whatever you want to call it. Not only that, you could just have a website deployed to a Kubernetes cluster exposed over a domain and say, hey, go here to do whatever you need. So the choice is really yours. And that's one of the things that we always try to strive for. I also want to mention just Kubernetes support because Kubernetes is difficult. Pulumi has 100% coverage of Kubernetes custom Kubernetes resources. So we support everything in Core v1, Meta v1, Apps v1, Batch v1, etc. But also we have this really cool tool called CRD to Pulumi. And what CRD to Pulumi allows you to do is generate rich SDKs in any Pulumi supported language from any custom resource definition. So as long as you have the ability from the project to download that little bit of YAML or maybe a big bit of YAML, you can generate SDKs in Node.js, Python, Java, etc. and etc. So when you combine all of these things together, you get a really powerful, rich editing and execution context for all of your cloud infrastructure. Next slide, please. Thanks, man. Lee's already covered a little bit of the code here. All you need to do to get started with this CDK integration and take advantage of the Pulumi primitives and superpowers is to create a class that extends the Pulumi CDK stack. From there, you write your CDK code and then call synth, just like you would with any other CDK program. And then from there, you can hook into Pulumi outputs, Pulumi secrets, and even Pulumi stack references, allowing you to pull values from one stack into another to modularize your infrastructure as code. Another great way to reduce that monolithic approach to infrastructure. And did we forget something? Well, Lee already kind of dropped the ball on this, of course, but we think this is just fantastic that we now have, there you go, CDK without CloudFormation. We have the ability to bring in all of those construct magics and use them with the Pulumi engine, removing the need for CloudFormation. Whether you love it or hate it, that's entirely up to you. The decision is yours, but we want to provide an execution context that makes sense for a wide variety of developers. Next slide. And with that, we're going to jump back to Lee's awesome demo, which is going to be sitting pretty and finished.
And of course, in this particular demo, I've run this. It looks like my AWS credentials ran out in the middle of this demo. So, what are the chances of this going flawlessly? But let's go and have a look at our standard Pulumi execution here. So what we ended up with when we provisioned our Pulumi program is that we get all of this command line output available to us. So it's provisioned all of the resources, the AWS cluster, the task definition, the service, all these things, and it's provisioned them still directly by talking to the API. I was very careful not to use the term CloudFormation, so I didn't, usurp David's amazing slide there. But by not actually talking to the CloudFormation API, you can see that the actual duration here, this happens by talking directly to the AWS API. The actual duration is relatively quick. We have great case studies from customers of ours that have noticed dramatic increases in productivity by being able to talk directly to the to the AWS API. And if this particular provisioning had been successful and my AWS SSO keys had not expired halfway through my provisioning, which is, of course, very typical of a live demo. Maybe it's because I use tmux. What you would have seen here is that it's provisioned all of these different resources. So you can see here it's provisioned this NAT gateway and the EC2 subnets and all of the different things here that you would need to actually provision an application. And of course, because I'm able to embed this directly into my, web application, I can now have full management and full control over how I want to present these things to users. So because the site didn't create successfully, I obviously can't delete it, but you can go ahead and create lots and lots of different things here. You can create management interfaces. If you are aspiring to create a platform as a service type model, this really will enable you to be able to think completely differently around how you allow users to provision infrastructure. So the last thing that I want to talk about before we take some time for some questions is just another dig into the code that we have here to talk a little bit about how this works. Because I mentioned already that we are able to just kind of map the AWS construct resources directly to Pulumi resources. The way that we do that is by basically taking what we call the type token out of the construct and mapping it to the AWS provider. And what's great about this is that we've made this flexible. And so if there are certain parts of the AWS, construct, CDK construct, that are not kind of mapped correctly, you can also create your own mapping as well. So you can see here in this adapter type, we're just basically looking for somebody trying to create a CloudFormation type of a scaling policy, and then we map it to a AWS scaling policy in the Pulumi resource provider. So this is really, really flexible. It allows you to really kind of choose your authoring experience, but of course it also allows you to choose your execution experience. And I think Rico mentioned this during the keynote, being able to choose that execution experience is something that I think a lot of CDK users and a lot of CDK community users are really trying to kind of get that capability. With Pulumi, you can get this from day one. And as I already mentioned, the amount of lines of code to actually build this entire platform as a service experience is under 250 lines of code, including the front end. And so you can see here, by being able to embed this into an Express.js web server, we're able to get lots and lots of flexibility. The final thing that I want to talk about, and I know we're running up towards the end of time here, the final thing that I really want to talk about is that while these are all written in TypeScript, and currently TypeScript is the only supported language to be able to import the AWS CDK language, you can turn these Pulumi these Pulumi component resources that we've created, you can turn these into multi-language components, which David already talked about. So you see here where we have this Fargate web application component resource, and we instantiate the Fargate stack from the CDK construct. This particular section here can be turned into a multi-language component. What's unique about Pulumi's multi-language components is that it is not a transpiler. We do not convert code from one language to another. It all happens in the Pulumi engine. And so when we create a Pulumi multi-language component, all that gets exposed are the actual interface arguments itself in the language of your choice, which means the management overhead and the amount of kind of knowledge that people need to be able to have in order to build these constructs is dramatically reduced, because you don't need to kind of debug a code transpilation error in JSII or anything along those lines. So that's all we kind of really had time for the demo. It's very typical that the one time that I do this demo in front of lots and lots of people, there's a failure. I ran this 20 times today, but hopefully you get the idea. And with that, I think I would love to take questions. You also will notice up here, the link to this particular demo with the multi-language component is there in the top. We can provide this in the cdk.dev Slack channel shortly. But with that, I think I'd love to take questions, and sure David would too.
All right. Thank you very much, gentlemen. That was great. And hey, got a little cursed by the live demo,
Absolutely.
that troll there. But so we got a couple questions coming in from the community. We're going to start with sort of a softball question for you. What's the advantage of using the Pulumi CDK interoperability versus using, say, CDK for Terraform?
I'll take that one, David. I think the main thing that we already kind of alluded to is because Pulumi treats the languages and language SDKs as first-class kind of citizens, the authoring experience is largely the same. The experience you get when you're writing your applications is largely the same, but the execution experience is dramatically changed. Because you can embed things into programs like we already saw with the automation API, you can essentially choose your execution experience. And, David already mentioned the universal infrastructure as code kind of concepts. We treat the execution experience as universal as well. David, I don't know if you have anything else to add.
Yeah, I mean, I think our automation API a really strong value add for anybody who's working on platform engineering teams and wants to be able to expose cloud infrastructure, even non-cloud infrastructure, just any resources supported by any provider to their users or even to internal development teams. So that's a bit of a game changer for sure.
Awesome. Are there any gotchas that somebody would need to know about adopting this Pulumi for CDK Interop? Anything that they should know, like, oh, we don't support these modules, or we don't support escape hatches or anything like that?
It is in preview, so that's obviously something to bear in mind. It's not bug free, and we expect that, you know, one of the great things about being able to do this presentation is that we're going to get a great community of CDK people to kind of kick the tires. We are committed to making this a first-class citizen of the Pulumi ecosystem, and so I guess the gotchas really are it's in preview, but there may be bugs, but please do give it a try it out, and what you find, and we'd love to kind of like fix those as they come along.
Okay, where's the best place for the community to engage with the Pulumi team on these things as they come up? Is there a Discord server, a Slack server, or is there are issues on GitHub the best place?
Yeah, so I mean, GitHub is a natural choice if people want to file bugs. We do have discussions enabled on our organization and on some repositories, but our Slack channel is probably the best place to get a quicker answer to things. So people can go to pulumi.com/Slack, join our Pulumi community, and we're always happy to help out if there's any challenges.
Fantastic. So another question from the community. Are there any plans to enable the dynamic provisioning of a CI/CD pipeline for the Pulumi app within the Pulumi code itself, in the same way that the AWS CDK provides the code pipelines module to be able to easily spin up a CI/CD pipeline for CDK code? Is there something similar, kind of a similar sort of functionality within Pulumi that you offer?
So this has actually come up before. You know, our execution experience is really like trying to find your own execution experience. Now you have full power of the CDK construct, and so you should be able to use the AWS code pipeline constructs that allow you to build those pipelines without trouble. So you know, we try to stay away from these kind of authoritative kind of CI/CD pipeline you know, definitions, but you should be able to use the code pipeline. And the other thing that you're able to do as well is define multi-language components that can define those things as well. Most CI/CD pipeline providers are static YAML files. Code build is unique in that it's not. So you know, if you want to define a GitHub action or something along those lines, you kind of need to define those static files, which is you know, kind of you are able to also make multi-language components as well if you wish.
Gotcha. Fantastic. So another question we've got here. So how easy is it to customize Pulumi for a specific environment, like custom endpoints for AWS services?
It's really straightforward. I think you just set configuration variables. So if you want to use the China endpoint or you want to use AWS GovCloud, it's simply you can use the AWS environment variables that are just instantiated normally if you set the endpoint environment variables. But you can also embed them in the Pulumi program. Pulumi has a similar concept of stacks where you can set configuration values. And so you would set, I can't remember what the actual stack configuration value is off the top of my head, but it's a Pulumi config set AWS :endpoint for that particular stack, and it will go to that particular endpoint, so the China endpoint or the GovCloud endpoint.
Gotcha. All right, we've got about another 5 minutes. Is there anything else that you guys want to chat about? We're looking still from questions from the community. So if you've got any questions for for Lee and David, go ahead and post them there in the YouTube chat there, and we will get them asked. So from your guys' standpoint, I'm very curious. Pulumi is, I would say, a competitor to the CDK in some regards. They are both trying to fill that same use case scenario of defining your infrastructure using a general purpose language. What was the driving force behind Pulumi trying to support the CDK?
Do you want to take that, David, or would you like me to take it?
No, I mean, I'll share some thoughts on that. I mean, I think it's easy to say because we're in the same space that we're competition, but I think competition means we're just all trying to help people with their infrastructure. So as long as you're using an infrastructure as code tool, doesn't matter which one, then we're all very happy. However, we do believe that Pulumi brings some really nice features to here, and we just want to help developers be more productive and increase their velocity, and that means interrupt for us. So we really do mean it when we talk about universal infrastructure as code. If you're using CDK, if you're using Helm charts, if you're deploying to Kubernetes, we want to provide a platform that allows you to use the benefits of all of these different ecosystems in one single API. So the drive for us is just hopefully to provide a good developer experience and keep people happy.
Yeah, and I'll add to that, like we take user feedback incredibly seriously. And I think the thing that we always get great feedback from people who adopt Pulumi, that their productivity increases dramatically. And we actually have, like I mentioned earlier, customer case studies that have talked about the increase in productivity that they've had from, migrating from other infrastructure as code tools. The one thing that I think we hear from customers is that the library, the constructs library that you have, and other infrastructure code libraries of like effective implementations, having that available in Pulumi would further add to their productivity. And we want to stand on the shoulders of the amazing CDK community that you have here. We have all these amazing constructs. We don't want to reinvent the wheel. We want to rewrite them and say that we can do this better. We know that the community is, in a great place of building best practice components. And so why not be able to use them straight off the shelf as they are? I think that's the main thing that kind of drove this decision. And, if you want to create a DynamoDB table and a Lambda function that talks to it, you can absolutely write it from scratch in Pulumi, and that is a very productive way to do it. But if you can just reach for that CDK construct and have that kind of created instantly, that is something that I think is really, really powerful for our users as well. And I hope that we are able to provide a lot of value to CDK users who are kind of trying to open the doors on that workflow execution mechanism. The authoring experience is largely the same. The execution mechanism, I think, is really where we believe that there's some improvements and some additions to be made there. So, lots of different things there, but I think that's the main kind of driver is just the amazing community that's been built here.
Awesome. I would agree. The CDK community has been absolutely fantastic. We've really seen it on our Slack server as well. Every single day, we've got people who are coming in as very fresh to the CDK world and are asking questions. And we've got really strong community members from all over who are all working to try to help each other out and get us all onto writing good code and everything like that. One other question we've got real quick. Is there a page somewhere that lists the feature coverage that we can check out to see the current state of the interoperability, like assets, escape hatches, lookups, and examples? Where's the best place to go if someone is really trying to adopt these things? Is there like one-stop shop for here's everything you need to know?
So as I mentioned, this is in preview. We expect to have all of that stuff available during GA. I just shared the link to the actual GitHub repo, and so this will be the best place to actually see all of the interoperability support. And we fully expect to have a nice, a nice breakdown of the different parts of the CDK ecosystem that Pulumi supports. And so this is the best place to go for the time being. It is in active development, and so I would encourage everybody to kind of kick the tires, try it out, see the different things, try it with different constructs and different parts of the CDK ecosystem. Let us know what you find. The feedback is so important to us because, we are, as we already mentioned, committed to making this a first-class citizen. And so the short answer for that is right now we don't have that kind of full breakdown. We expect to have something like that for GA. And we look forward to that time.
Fantastic. Well, I'm going to go ahead and we just created a Pulumi channel on the cdk.dev Slack server. If you guys aren't already part of that server, I highly recommend you join us in there. Maybe you can join on that channel and answer any questions that come up from any of our users that are trying to adopt it there. We're just about out of time. Thank you, gentlemen, very much for joining us today. We really appreciate it, and have an excellent day.
Thank you very much.
So much.
Yep. All right. Fantastic. Well, hopefully that was really interesting. It's always great to see how Other products like Terraform, like Kubernetes, are starting to adopt this, CDK construct mentality on things. Now, next up, we've got a gentleman named Eli. Eli, how are you doing, sir?
Good, Matt. How are you doing? Great to be here.
Great to have you. Well, you're going to be talking to us about Kubernetes, aren't you?
Yeah, it's actually very in line with what David and Lee just spoke about. So hopefully it should look familiar.
Fantastic. Well, thank you, sir. It is all yours.
All right. So the screen is okay, I hope. Okay, so hi, everyone. My name is Eli Polonsky. I'm a software development engineer at AWS, working on the CDK, specifically on the CDK for Kubernetes and CDKs. So let's have a look at what we're going to talk about today. So our agenda is, first, we're going to describe what are we going to be doing here, what problem we're going to try and solve, what use case we're going to address. Like I said, it's very similar to what we just saw with Pulumi, so you have some context there. Then we're going to dive into how are we going to do this, and this is where tools like ACK and CDK-defined come in, and we'll talk a little bit about what they do. We're going to see a demo. I'm not brave as David and Lee, so I'm not going to do this live. We're just going to see some code snippets and an already pre-built deployed environment. And then we're going to talk about some takeaways from all of this experience. Okay, so what are we doing here? So just to set the scene, let's say I'm an AWS user deploying applications on Kubernetes. And now I'm writing a new application, or maybe I'm migrating an old application that simply has a deployment in it with a container that needs to talk to an SQL database. Now, since I'm on AWS, I want to use managed services as much as I can. And specifically here, I want my container to talk to an Amazon RDS instance that's backed with a Postgres engine. So this is my application. It's very, very simple. And the question now becomes, how do I do this? How do I, as an AWS and a Kubernetes user, do that without necessarily rocking the boat too much, without changing my development workflow, without changing my authoring experience? How do I make this seamless? This combination of Kubernetes resources and AWS resources. So this is where CDKs and ACK comes in. So on the left, you can see that this is basically how you would define this application using pure Kubernetes manifests. On the left, you can see the core Kubernetes resource, which is a deployment. And this is its definition in YAML. This is what you would have to write in YAML to make that happen. And on the right, this is the new product that AWS recently launched. It's called the AWS Controllers for Kubernetes. And it's essentially a way to write manifests in Kubernetes that provision AWS resources instead of Kubernetes resources. So you can see this one defines an RDS DB instance with an allocated storage of 100 gigs and a DB instance class and all the things that we're familiar with. But obviously, this is CDK Day, so we don't want to be seeing a lot of YAML on the screen. So what we want to be doing is, instead of this core definition with YAML, we want to be using CDK-defined to do that, right? With its intent-based APIs. And instead of writing manifests to provision a DB instance, we want to be using the AWS CDK because we like the intent-based APIs it provides and the abstractions it provides. So now there's a problem, because if we're using the AWS CDK, we are by default choosing a provisioning engine, right? We're choosing CloudFormation, and of course, as Lee and David already showed, that's not the case anymore. We can choose different engines, but right now we're focused on this Kubernetes ecosystem, right? So we want to stay in the Kubernetes experience. So how do we use AWS CDK constructs along with CDK's constructs and have it all provisioned with Kubernetes without any additional tooling or engines? Okay, so, and this is basically CDK all things, right? This is the authoring experience that we want to have. Okay, so let's jump into the demo here, and let's see what we have. Okay, So this is the application code that we want to be writing as CDK users. And let's see what we have here. We have a PostgreSQL construct that uses AWS CDK library, right? It has the AWS CDK imports, and it imports a VPC, it imports a security group, and it defines a database RDS instance using the AWS CDK APIs. It then takes those attributes from the DB instance and just exposes them on this construct so that other parts of the application can access it. So this is our AWS construct. Pure AWS, has nothing to do with CDKs or Kubernetes. Now we have this other construct, and you can see they all extend construct, right? They don't extend a stack or a chart or anything else. It's just pure constructs. So this is our a workload construct that defines a CDK's deployment or a Kubernetes deployment using CDKs. And you can see that we're just creating a deployment here with Amazon Linux public image from the public ECR gallery. And just for the sake of the demo, we're just gonna have a little while loop here that runs forever. And the nice thing about this is that this application, like we mentioned, needs to eventually talk to the database. So what we're doing is we're passing in those database properties as props to this workload resource. And we're adding those as environment variables to the container of the deployment. So this is how you would add environment variables in CDK+. Right? So this is the DB address and the DB port that comes from the properties of this construct. Okay, now let's have a look at the combined thing. So now we want to combine those two. We want to instantiate the RDS instance and extract its attributes, its runtime information, and pass that on to a CDK's construct. So this is our RDS instance chart. And this is a special chart. And this is the new project that I've been working on with the team recently. And it's called the AWS CDK adapter for CDKs. And you can see that it has this special chart class in it. And all you have to do to use it is have your chart extend this chart class. And that's it, basically. As soon as you're extending this chart, you can instantiate AWS CDK constructs. You'll notice you're just passing in the scope as you would normally pass in. You'll also notice that you're passing in AWS CDK tokens or attributes, runtime values seamlessly, just like you would in the CDK world, in the AWS CDK world. Okay, so now let's have a look at what this thing actually synthesizes, and we'll talk about a little bit of the magic that's happening behind the scenes here. So if we look at the manifest here, this is our manifest that CDK synthesized for us. So this is the deployment object. All of these different values are auto-generated or auto-wired by CDK+. We didn't have to write all of these. All of these default values are exposed, so we know exactly the behavior of the deployment. And this is our command. And this is where things get interesting. So if you look at the environment of this container, remember that the environment variables of this container need to come from the AWS resources, right? So in Kubernetes world, you can reference environment variables using config maps. So if there's a value in a configuration map, that value can be taken out and used as a value to the container. And what happens here is that this thing gets auto-generated and uses something called field exports, which is the ACK way of exposing runtime information. So if we look at another resource here. All right, so 1 second. Okay, so this is something called a field export. And what this field export does is tells ACK controllers to take this field from the resource, from some resource, and put that in a config map, right? And now, if it's in the config map, we can then use it in our container definition. And so we're doing this for the address, and we're doing this for the port. And this entire thing is what the adapter actually does. The adapter looks at the construct tree, looks at the synthesized properties, and detects those tokens, those runtime attributes, and actually converts them all to field exports and config map refs and all of the things that are, to implement that in the Kubernetes domain. But you as an author are not exposed to that. You're just passing properties as if you would in the CloudFormation world or in the CDK world. So this is one cool thing that ACK can do and that the adapter can do. Another thing is, okay, so let's also look at the resources, the AWS resources that we have, right? So we configured an RDS database instance, and we can see that we have an RDS database instance here with all the defaults that the CDK provides for us. And we can also see that there is a DB subnet group. Again, we didn't provision the DB we didn't define the DB subnet group. We just defined an RDS instance using CDK. But CDK does that for us. And you can see that resource being defined here using the ACK definitions. Okay, so this is basically how that would look like. Another point I wanna make is that if we look at the actual CloudFormation template, the original CloudFormation template that would have been synthesized if we provisioned everything with the CDK by default. So this is the CloudFormation template, right? It also defines a DB subnet group and a DB instance. And we can see that this DB instance actually has a reference to the DB subnet group. Now, this reference it gets lost, or not lost, it gets automatically resolved to static values during CDK synthesis, because in Kubernetes, every resource needs to have a name. The metadata.name property needs to exist for every single resource. In the CDK, that's not the case. And in CloudFormation, that's not the case. So what this adapter using CDK does is it generates names for you before deployment. So all names are known at synth time. And then it automatically resolves those references between resources using the logical IDs of the resources and extracting its name. So you can see that the DB instance, the DB subnet group name here is just the name of the DB subnet group. There's no dynamic references here because everything is known at synthesis time. So these are the two kind of features or magic features that are happening here. One is automatic attribute resolution, right, and wiring using field exports. And the other is ref resolving using statically known names generated by the CDKs. Okay, so let's have a look at the environment that actually got deployed. All right, so this is the AWS console, and if we go to the EKS console, sorry, I should have done this before. We have this ACK cluster here. So the ACK cluster, it's a Fargate cluster. I provisioned this cluster using the AWS CDK natively because you need a cluster to provision all the other resources, right? And if we look at the resources here, so there are a couple of interesting things. If we look at the ACK system namespace, you can see that there are pods here which represent Kubernetes controllers for every AWS resource that they support. So there's a Dynamo chart, the DynamoDB, EC2, IAM, Lambda, RDS, and S3. Given these controllers, these are the resources that I can provision with this EKS cluster. If I need additional resources, I'm going to need to deploy additional ACK controllers. Now, if we look at the default namespace, this is our pod, the one that we just deployed. And you can see that it's running, it has one container. And just to complete the picture, if we're going to now, query the container, the logs for the pod, and just see that those environment variables got passed in properly. So if we look at the logs here, this should, yeah. So my container is just a small bash script that prints out those environment variables, right? So these are, you can see these are runtime values being passed to the containers from AWS resources to CDK's resources or to Kubernetes resources. Okay, so that was the demo. I hope it made sense. I think it's the same type of approach, right? We've seen that it's much easier, and we like defining AWS resources with the AWS CDK. Sometimes we want to have a different execution environment or a different execution engine in CloudFormation, whether it's because we just want something else, or whether it's just because we're already using Kubernetes and we want to stay in that ecosystem. So that thing, this project now allows you to do that. All right, so let's go back to the slides here. So what are the takeaways here? This project is not as extensive as the Pulumi provider, or as we'll see, I think this is running in parallel, the Terraform adapter. It's just a POC at the moment. It's just kind of my attempt to see if this is even possible. And good news, it is possible. This is an application that you can write now. It is hard, though. It is hard because of a few things. One is that ACK does not currently support Cloud Control API. And not supporting Cloud Control API means you need to be doing those mappings that David and Lee spoke about. You need to be doing all of those manually. So right now, the adapter supports about 4 or 5 of those resources or of those mappers. You can also register custom mappers in your application. So if your application needs one more resource that isn't supported by the adapter, you can just add that mapper to the application. But it is a limiting factor here, and we'll see where the ACK project lands. There's also an option of actually building and code generating ACK controllers. So maybe there's a way to generate a Cloud Control API controller for that. There's also limited support for intrinsic functions. I did show you the resolution of FN get attribute or runtime information, but those values can only be placed in very specific parts of the manifest. It can't be used across the board. It's not a feature of the language. It's a feature of a specific resource. And right now, there's also a substantial coverage gap in ACK itself. So the resources that ACK currently supports, it's still in beta or a preview. They're working. The team is working hard on adding more resources, but right now there is a coverage gap there. The other takeaway that I wanted to mention here is that this implementation of the adapter is the third implementation we've seen in this CDK day and recently of taking the AWS CDK and outputting different artifacts, right? Not CloudFormation templates, but something else. And I can tell you from my personal experience implementing this, there were quite a few hacks that had to go into the implementation. They're not exposed to you as a user, but obviously we don't want to have all those hacks in the implementation because that's not a good experience. So I think that we as a community, we as the AWS CDK team, as the CDK team, we need to kind of regroup around all of these different implementations and think about what can we upstream to the AWS CDK, or even a lower level, even to constructs. Can we add custom synthesis mechanism to constructs? Can we add aspects and tokens, which are currently implemented both in Terraform and the AWS CDK separately? So all of these questions, we want to be thinking about, and let us know what you think about this as well. A couple of resources. So this is the new repo for the adapter itself. If you want to learn about the ACK controllers for Kubernetes, this one's the site, and of course cdks.io. And I think I'm just about at time.
Wow, that's fantastic. Thank you so much, Elad. That's really amazing. So I want to make sure that I got that because there was a lot of stuff that was covered there.
Yeah.
So you've now proved out this concept that you can write CDK code constructs
Right.
that leverage AWS CDK constructs
Right.
to generate ACK resource definitions for provisioning AWS resources.
Yes, 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 and yes. Now, but the idea is, again, is if you're looking to leverage all of these intent-based APIs, the things that we're working on so hard, right? The handwritten APIs, and maybe not even the handwritten, but the idea is you don't want to be writing manifests, YAML, obviously. You want to be using those constructs, but you don't want to necessarily be tied to a provisioning engine because you're using those constructs. So the decoupling of an authoring experience from the execution experience, which is a theme that we have in the CDK day to day, this is another example of that.
Yeah, really. I mean, just more and more we're seeing that these constructs that the AWS CDK team put together and that other third-party developers are putting together really are becoming just a definition of resource, and that underlying engine for how to provision it is just going to get swapped in and out all over the place depending on how you want to do it, whatever fits well for your business. And that's incredible.
Exactly.
It's great to see that sort of thing go. So thank you very much for your time today. We really appreciate it. We can't wait to see where this goes in the future.
Thank you. All right, and let us know on the repo. It's brand new. It's waiting for your feedback.
Will do. Thank you. Appreciate it.
Bye, guys.
All right. Really amazing. So next up, we're going to have a gentleman named Bradley Campbell. He's going to be talking to us about organizing CDK Terraform code in projects. So welcome, Bradley. Great to have you here. Thank you very much. And it is all yours.
Awesome. Great. So I'm Bradley Campbell. I'm a full cycle developer at Osedia. We're based in Montreal, in Nantes, France, as well as in London in the UK most recently. And I've been working with the Terraform CDK for the last little bit, kind of in an exploratory phase to kind of see what we can do with it. And I just wanted to share some of the tips and tricks that I found with keeping my code organized and the things that I can do in it. So just a little summary. First, I'm going to just touch a little bit on where we're at with the CDKtf at Osedia. Then just for a bit of context, I'm going to talk a little bit about stacks and constructs in the Terraform CDK. Then I'm going to jump into some code and show some examples in a sample project, and then finish off with some takeaways. So I said that I'm a full cycle developer at Osedia, and that kind of goes with our philosophy that we want developers to have an understanding of all phases of the development cycle, from developing locally to deploying an application to the cloud. So if you want to read more about that, we have some information on our blog, but that's kind of what brought me into learning about infrastructure as code and the Terraform CDK specifically. And at Osedia, we've been working with Terraform for a while. So that's been a solution we've used for infrastructure as code. And we have quite a few modules that have been developed with HCL. So it's really great how with the Terraform CDK, it's all of those modules are really plug and play. So it wasn't very hard to get up and running in the Terraform CDK and using those existing modules that we put a lot of work into. So at this stage, we're really kind of exploring how the Terraform CDK could bring value to our organization. And we're working on seeing how we can kind of implement it more widely among throughout our projects. So just to give a little bit of context before I get into the code, I'm going to talk about stacks. So that's kind of the main way that that resources are provisioned in the Terraform CDK. So a stack is basically a group of resources treated as one Terraform configuration. And if I were to kind of have a hierarchy, the top of the hierarchy would be your CDKtf app. And then inside that, you can have one or many stacks depending on how you want to divide up your resources. And you can also reference different stacks. So a stack can reference a resource from another stack. Now to talk about constructs, this is something that's made possible using the AWS constructs library in CDKtf, and it could be used as a generic term to refer to the different pieces of your project. It could also refer to custom constructs that you create with different levels of abstraction. So ranging from, you know, a really simple construct that just has a couple of different resources in it to a more complex construct that implements kind of a big chunk of infrastructure or a bunch of resources that work together, kind of isolated on their own. So constructs are a way that you can further kind of group your resources within stacks. And they must be instantiated inside a stack as well. So stacks are instantiated inside the app, and then inside your stacks, you can either have your resources directly, or you can have you know, various constructs. So now I'm going to pull up my code just to show you what I have going on here. So this, I'm working in TypeScript, which I like because I find it takes less time to compile the HCL modules, since it's just compiled into JSII, and I'm more familiar with TypeScript anyway. But this here, it's kind of like the entry point into your application, the main.ts file. And what I like to do is I like to break up my resources logically into different stacks. So in this example, I've created a front-end stack and a back-end stack. And there's a resource that's being shared between the two, and we'll take a look at that in a little bit. But since I have two separate stacks, I've actually created a reusable base stack that provisions some common resources. So just taking a look at this, this is my base stack, and the idea is that this could then be extended, and anything that's available inside the base stack will be made available in the extended stack. So a couple resources I have here, I'm using the label null module from Cloud Posse, and that provides a way to have like a consistent naming convention across your modules. I'm also instantiating the AWS provider in here so that it's set up in the base stack, and I'm using AWS in both stacks. And in here, it takes a region, and the credentials are passed as environment variables. I also have a few kind of optional resources in here. So we'll take a look in a minute, but I've created a construct to use the 1Password provider. So that's a way that, you know, if you wanted to save your credentials in a 1Password vault, you could interact with the 1Password provider to access those, and then those are passed to your AWS provider. So that's an alternative to using environment variables. And then for the backend to manage the TF state file, you can either pass a configuration for an S3 backend if you have an S3 bucket and DynamoDB table for state locking set up, or you can configure a remote backend using the Terraform Cloud remote backend. And what I've done also is I've created an interface that contains all of the configurations for these. So what's great about the CDKtf is that you have type information for all of the values that need to be passed to this interface. So for example, if you want to use the S3 backend, you can easily check to see what the required values are and what you can pass to it. And so it makes it so that the information, it's readily available to you. So I'm going to jump over to my front end stack now, just to take a look at how I extended. So we can see I've created an interface to configure the front end stack, and I'm extending the base stack. So everything that exists inside the base stack is already there. And then there's a few extra things that we need to pass to the front end stack to instantiate it. In here, I've created a construct to set up all of the resources needed for the front end stack. I'm not going to go through that because I don't have time, but we will take a look at a smaller construct. But basically, you can pass the label null provider that's available since you're extending the base stack, as well as a few other variables, and that's going to set up your front end stack with like a default. There's like a default setting to get that up and running, and then afterwards you can access the modules that have been created inside the construct, and add any modifications that you need. So for example, here I'm accessing the CloudFront module that was created inside the construct. I'm spreading the origins that exist in the default setting, and then I'm adding a new origin for my backend application. And that's going to use the values that are passed in the config. So I'm going to jump back to the main file just to show what that looks like when you're instantiating it. So here you can see that you just need to pass in all of the values required for the base stack, as well as the values required for the front end stack. I also have the backend stack that was defined before the front end stack, and I've used a variable for that, so then I can access the load balancer DNS name and the ACM certificate that have been created inside the backend stack. And whenever you go to deploy this, the Terraform CDK will know that there's a dependency between the stacks, and it will deploy them appropriately. So I just want to jump into talking about the constructs now. So I have this 1Password construct that I've created. So it has a configuration just like the stacks that I created. So it's going to take the host URL, the vault UID, etc. There's a step that you would need to do to set this up with your 1Password. Using 1Password Connect. But what I'm doing here is I'm setting up the 1Password provider, which takes a configuration token and a host URL. And then once I set that up, I'm accessing the account ID and the account secret key for my AWS account. And then I am making those accessible as read-only values, which then in my base stack, if I pass a 1Password config, then it's going to know to read those values and pass them to the AWS provider. So just to take a look at, again, at the main. So for this in the main, I didn't actually set it up, so I won't show you that, but I will show you here. This is an example of if you were to set up a S3 backend for your Terraform project, you could pass in the S3 bucket name that's created to handle your state, the DynamoDB table, and then the key for what you would want to call your TF state file. So that is what I have for that. I also can show the backend stack a little bit. So in my backend stack, I have created a construct that handles most of the architecture. So it's basically setting up a deployment using Fargate. And there's a default container in there, but you could also pass an array of container definitions if you want to customize it. But what I've done here is I've set up a VPC, and then the VPC gets passed to the backend construct. And the backend construct can then access all of the values that it needs from the VPC. We're going to pass the domain name, the zone ID for the DNS, and then the label null module so that it can handle naming. And then I'm making the DNS name and the ACM modules. I'm exposing those so that those can then be referenced by the front end stack. And then I'm outputting the repository name for the ECR repository that's created by default, and then the repository URL for the repository that's created. So that's about everything that I wanted to show. So I'm just going to jump back to my slideshow. So just a few takeaways for some suggestions of how you could set up a project. This is really a first iteration for me. I'm really kind of exploring and kind of seeing what the best way for me is, but I'm really happy with how much I've been able to explore with the Terraform CDK. Some things to remember are that you can separate logically linked resources into stacks. So like what I did, I created a front end stack to handle all of the front end related resources, and then a back end stack. You can keep your main file tidy by splitting up your code. So instead of defining your resources within the main file, you can actually create separate files for each stack and then take care of provisioning your resources inside your stacks. Use cross-referencing to share resources between stacks. So if you have a resource that one stack needs to access from the other, rather than putting all of your resources just into one giant stack, you can really cross-reference them, and that allows you to kind of split things up a little bit more. And then use constructs to combine groups of modules and resources within stacks. So if you see fit, you can create constructs that have like, just a couple of resources if that's the way that you want to group them, or you can create constructs that implement larger architecture patterns and then make those reusable. So the next thing that I kind of want to learn more about is being able to publish those reusable constructs and being able to reuse them over different projects. So that's kind of one of the next things that I want to learn. And yeah, that's everything that I have. So thank you everyone for listening, and enjoy your CDK day.
All right, Bradley, thank you very much. That was really great. And one thing I want to highlight here, you were talking a lot about, CDK for Terraform, but in fact, all those takeaways that you gave are great to apply to your CDK's code, your AWS CDK code. They still apply. So if you're listening in and you thought, oh no, this is just for Terraform, no, that this is for everything, and great lessons. And it's a common question we see in the CDK dev Slack server. It's a common question we got around from the book as well, how do I organize my files? And I think you hit the nail right on the head. So thank you very much.
Awesome.
We really appreciate it. Thank you for the presentation, and have a wonderful day.
Thank you. Bye.
Thanks, Bradley. All right. Moving right along. So we have been going now for almost 2 hours. And to wrap up the first 2 hours of this, we're going to have Mr. Ken Winner on today.
Hey,
oh, there we go.
Yeah.
Good. How you doing, Ken?
Not too bad. Beautiful rain.
Fantastic. Yes, it is. Well, here in Colorado, it's gorgeous, but I'm not sure where you're at.
Indiana.
Well, there you go. Indiana, it's raining. There's the weather report for the day. Well, Ken, you're going to be talking to us about parallel CDK stack deployment, right?
Yes, yeah. So I wrote a blog post about this, and I thought, we could turn this into a live session and kind of see where it goes.
Fantastic. Well, thank you very much. It is all yours.
All right. So we're going to work through a couple contrived examples of stacks and kind of create those pretty quickly. So I only have this one slide, but I'm Ken Winter. I'm an engineer at Steady. Like I said, I wrote a blog post about this and thought it might be good for folks to kind of see how we went through and what the process was and how you can make this your own and, see what the differences are between a serial deploy and how fast we can get with this. Afterwards, you can find me on the CDK-dev Slack. Everything for this will be on GitHub, and you can always reach me on Twitter. So let's go ahead and drop that. I'm going to start with a blank workspace here. So empty repo. We got nothing in this project. So we are going to create a new Projen app TS. We don't want to synthesize it yet. All right. I do have a couple things already prepared. For the most part, we'll try to. Oh, well, that didn't work. That's because we need this. All right, the benefits of a live demo. There will be some sort of dead space that we need to fill while we're deploying. So I'll go through the stacks and the setup pretty quickly, and then we can kind of talk through some of the things that we have. So you will notice I'm going to go ahead and use CDK version 1.x. And the reason for that is I want to switch to this if we have a little bit of time later. We can show how quickly we can just migrate from 1 to 2. These are all the dependencies we're going to go ahead and use. We do want some ES build. Well, we don't really need it, but just copying some pieces from some other stuff I have. Additionally, I do like to use npm instead of yarn. So we will go ahead and grab that piece as well. Let me go ahead and zoom in so this is a little more legible for everyone. All right, so there's our basic setup. We'll go ahead and run npx projen. I have that alias to pj here. And we got our basic structure of a project. Gonna move some stuff around. Everyone kind of has their own format. I like to put things in a stack. A couple different stacks we're gonna create. Something that you might have yourself. We'll do something, a data store stack with a Dynamo table, a secret stack with some secrets manager secrets, an ingestion stack. Maybe you have a Firehose with data coming in, a webhook stack, an async job stack with like a fake reporter function. And I think I said all of them, and a dashboard at the end that will rely on everything. So we can kind of see 3 tiers that depend on each other, and we'll go from there. So let's start with our data store stack. And if we come over to main, we'll cut this out. We don't care about that. Don't care about this. And then we will drop some code in here. We want to import. All right, we're going to call this data store stack. And we want to create a new table. So let's say we have public read-only table, and we want to pull this in from DynamoDB.
Hey Ken, real quick, we had some questions from the server. Could you, or from the channel, could you zoom in just a little bit on the code there so everyone can see it a little bit?
Yeah, we can go in a little more. How does that look?
Thank you very much. Appreciate it.
Yeah. All right, we got a table here, and everything's going to complain about me because I use prettier, and this isn't using the setup. So that's why. So this dot table is a new table. And we'll just say, doesn't really matter. Everything will kind of fix itself. We're going to call our PK. The type will be attribute type dot string. And all right, that's all we need. So that's it for our basic data store stack. So now we want to pull that in. And I have, just to make things a little easier when I go to delete everything later. So we're just going to call this, and call this data store. All right, so now I got one stack. We might want, I'll go ahead and create these from everything that I already had, because we're running a little tight already. So we've got an API stack. This is just going to take a basic function and then a Lambda REST API handler and grant access to the table. So this relies on the table secret 1, secret 2. And then we are going to create an async job stack. So this will take another, basic Lambda function and call it reporter function. Again, we'll give it access to read from the table, read the secret. And we also push these functions out. If you add multiple in here, that'll help us build our dashboard at the end. And then we need the dashboard stack. I'm going in alphabetical order because it's a little bit easier. So this will build our metrics. So we'll take in the functions that we have from the different stacks, and we'll also take in our table, be able to build that out. An ingestion stack, we're going to create a Firehose delivery stream. So we create a bucket and then a delivery stream. Let's do the secret stack now. So 2 secrets, one called secret 1, one called secret 2. Maybe they're an API key, whatever. The webhook stack. So a couple basic functions, one called webhook function 1, webhook 2, and that's it. So we're at 3, 6, 7 stacks. All right. Now we can close all these. Come back here. We need to pull all these in. So we'll go ahead and do this. I already have a little bit of this prepared. The data store stack does not exist. That's because we didn't use the same one. Okay, here we go. All right, so those are the basic stacks that we are going to create and kind of deploy. So next for the meat of everything. So let's create a new folder. And these are the pieces that kind of build your graph for doing the graph deploys. So we need our stack dependency generator. So we borrowed a little bit of code from the good folks over at Serverless Stack. And we'll call this stackdeps.js. Once I deploy, we'll go back through and kind of review these things, but the deploys take around 10 minutes. So then we need our generate stack graphs. Okay, so we're going to declare 2 different stages, one called graph demo, one called graph prod. And then it'll use this stack deps here that grabs the manifest. Then we need to create our workflows. All right, we're going to do 2 at the same time. So one is going to be called serial deploy. If this will, here we go, serial deploy. And this will do something kind of standard where it'll say, okay, go ahead and build, then it'll deploy to the demo environment, and then it will deploy to the production environment. And then we'll call this one graph deploy. And this will use our generated graph, and we'll get all the niceties that we want. So let's say we need to grab all this. All right, so we're going to create a new task called generate stack graphs, and then we're going to create bin generated stack graphs that will run that file that we created here. And then these two workflows that we wrote, one for serial, one for graph. So let's fingers crossed and hope everything works. And of course it did not. Let's go ahead and reinstall real quick. And missing write access. Perhaps when we created it, we did a few things kind of out of sync. Drop that, and all right. Well, this is fun. Kind of fix things on the fly. And so we should have Projen in here. Yeah. Maybe a clean install will kind of fix this up. Okay, here we go. Good as new. It wouldn't be a demo if we didn't run into some issues. All right, now we're kind of fixed up and clean. All right, here we go. Now we can run generate stack graphs. So here we will create a generated folder, and it should be probably a little bit of code missing that will create the directory if it doesn't exist. We can kind of clean some of those things up before we publish out. All right. So now if we pop down to generated, you can see this graph. We've got graph demo, and then we've got graph prod. So let's go ahead and add everything. Make sure we're good. We'll just say initial graph workflow. And we didn't do that. I don't know about most of you, but I always forget these commands. So we're going to go here, and we can push out. Oh, we just did. All right, so now everything's up and live. We have our two actions, and this graph workflow doesn't work. So we're off to a good start. So here's the serial deploy workflow. We've got to build, deploy serial, deploy prod. So let's take a look at why the graph one didn't work. Because I didn't rerun Projen after we generated the graph, so the graph wasn't updated in the graph deploy. You know, make some really good commit name choices with chore fix, and we should have our graph deploy off and running. All right. So for credentials for the AWS environment, we're using the AWS Actions configure AWS credentials. And so one piece that we had to set up previously was this OIDC token provider, so that we could grab our credentials, and then in the settings, we created a secret called OIDC role. So that's what these are using. And here we can see we have no stacks rolling in yet. Everything must still be in the build phase. So let's drop back over here and kind of explain some of these pieces. All right, we've got the stack deps, which will grab everything from the CDK out manifest.json and build our stack dependencies based on grabbing, the API stack depends on the data store stack. So it will kind of link all this together. Then when we generate our stack graph, we write it out to generated graph.json. As you can see, this code here didn't check to make sure that directory was there, which is why we kind of failed. You can declare, any number of stages you want here. In the blog post, we only did demo. So here we'll actually see demo, and then we'll go to prod. And what this does is we then have where did I put those workflows? The graph deploy workflow. So this is kind of the meat of the magic. And so we recreate the basic deploy workflow from Projen that it generates. So we have a basic build, we have some different conditions, we have the anti-tamper steps. If you're familiar with Projen, you may be familiar with some of these steps. Then we run the Projen build command. But then if we scroll down, here we have the graph deploy workflow. So we have a couple stages, demo stage, prod stage. And then we also have some artifacts that we push out so that we can reuse that artifact and don't have to resynthesize in every single step. So we grab that generated graph. If it doesn't exist, then we do nothing. So here we have the demo jobs. So we add our stage jobs and we pass in the build job because all of those need to require the build so that we make sure we have our artifact. And then we have the prod build job. And this morning I made a small change that one of my coworkers suggested. And we build this while the others are deploying. And then once we get to the stages for production, it's already there and we can shave off about 30 seconds in deploy time. And then we add those stage jobs based on the graph. And here we pass in this needs demo jobs. So this is all a JavaScript file. So there are no types or anything if you go to port this yourself. However, it's easy to kind of fix up. So add stage jobs. We loop through all of the stacks in this stack graph. And just for reference, we can look at the graph.json. So here are all the stacks, right? We've got data store graph prod. We've got secrets graph prod, and you can kind of see the dependencies listed in there. So that workflow is just looping through all of those stacks and using the needs functionality to kind of give us our nice, neat graph. And then we also do this CDK deploy exclusively stack name. And here's where we use that artifact. And a couple of niceties like timing out if it takes 20 minutes. Sometimes GithubActions messes up and you don't want that to kind of be spinning there forever. So this is the biggest piece. Personally, we run this on our own Projen project. And so we have both of these available. If a project has 7, 8 stacks we want to deploy, graph might make sense. If it's only 1 or 2, serial deploy might be better. All right, so the builds all failed, so that's good. We should have checked that first. We didn't fix the tests. However, I will push this. We only have a couple minutes left. I'll push a fix, and you can go look at this, and it takes about 12, 13 minutes to deploy the graph version, and then it takes about 17 minutes to deploy the serial version. So if you check back later or you're watching the recording, you'll see those changes, and then I'll make one more commit that you can look at that will upgrade to CDK v2, and you can kind of see how fast that migration process takes. All right, if you have any questions, again, you can find me on Twitter, the CDK Dev Slack, or check out the GitHub.
Awesome, Ken. That is really cool. A lot of people have been asking a lot about, how can we speed up our deployments and things like that? Because it seems like everybody's always, antsy about, oh, I got to get a code change out now. Is this something that you plan on contributing to the Constructs Hub?
That would be a possibility. Here, I'll show this because I had a working practice version. I'm curious if what kind of construct I can make out of this. That might be a good exercise for this American holiday weekend. See what we can come up with.
Yeah, spend your holiday writing code.
Yeah, exactly.
Perfect. All right, sir. Well, thank you very much. We really appreciate you. Thank you for coming out just for CDK Day, and hopefully we'll see you around.
Thanks, Matthew.
Yep. All right, so we have a very special speaker coming up next. Some of you may know him. You'll probably recognize him if you've been in the CDK community at all. This is Elad. Elad, welcome. How you doing?
Hey, it's awesome to be here, guys. Hey, Matthew.
Welcome.
Hey,
Welcome back. We miss you. So, this is just going to be sort of a general catch up with Elad section. So, how about you start us off? Tell us a little bit about what you've been doing.
So I, left Amazon in February. That's been a very big event in my life after 7 amazing years. It has been an amazing ride, actually. I loved every minute of it. It was inspiring and empowering, and past 5 years building the CDK there, which was incredible. It's unbelievable to see it. Like I'm watching CDK Day, and it's like just my heart is expanding. Like seeing people talking about these tools that we've been building together, and the passion that people bring into this community. And I feel like this passion is just, it's exactly how I feel about it. It's just this when you're using the right tool for the job, like there's this like internal feeling that that you're doing a professional work, right? I remember my dad used to say every time we work together in the house at the weekend, is like constantly drilled into me. Is like, first, make sure you're using the right tool. Don't use the wrong screwdriver. It'll take like 50% more of your efforts. And so it's been like this very kind of like mission in my life to like make sure that I always use the right tools. And I've always been this annoying kid, or the annoying developer who would build their little tools and shove them to their friends, and the team is like, hey, here's my little new build system, try to use it because it'll make your life easier. And finally, after a long career, 5 years ago, I managed to kind of make it my day job with the CDK. So it has been definitely the highlight of my career so far. And but in February, I kind of felt that the CDK is in a great hands. The team at Amazon is an amazing team, and I miss everybody there. I think they're doing an amazing job, and I think they'll continue to do an amazing job. And I think like we've kind of laid the foundations of that ecosystem, of this paradigm. And so I didn't feel like I really needed to stay in order for it to continue in that direction. And I've also seen this community forming around this project, and felt that these are also really good hands, right? And so I feel like this, it didn't feel like I need to specifically stay in the Amazon in order to continue to make that work. And sorry, my timer to get ready for the talk, and also give people in the CDK team and in the community more opportunity to like find their place. And so it was great. It was an amazing experience leaving Amazon as well. I got so many emails from people across the company who I've never talked to, but they're using the CDK day to day and they love it. Amazon's, naturally is a huge user of the CDK. And I think just before I left, someone told me that they added CDK to like the Amazon SDE bootcamp. And so every developer that goes into Amazon learns about the CDK. And so even at that level, it's like super encouraging and amazing to see. And after leaving, I was kind of like starting to talk to people, because I felt I definitely have blind spots. After 7 years at a company like Amazon, which is also very unique in its engineering culture and how it's approaching engineering problems, I was certain that I need to learn about what's going on in the industry around cloud and cloud development. I definitely wanted to continue to do this. Like I love software engineering, I love developer tools, I love the cloud. I think like all of those things are very aligned with what I've been doing throughout my career, and especially the CDK. And so like still interested in this. So I started talking to lots of people, kind of getting familiar with the Israeli tech scene, which I wasn't super connected to working with it at Amazon, because the CDK team is like distributed around the world, and didn't have too many connections, and so started to kind of like create these connections. And the Israeli startup community and ecosystem is just incredible. And everything is like 10-minute walk from my house. It's just like it was such a refreshing situation. After I've been at Amazon for 7 years, and throughout these 7 years, I've worked remotely. And so suddenly I'm meeting people face to face, also post pandemic. And so it was really nice to just like, hang out with people and talk to VP R&Ds and platform engineers and CTOs and founders and investors in Israel, talking about things that they're doing and building, and obviously interviewed people about their experience with the cloud and the pain that they have. And there's this constant, there's like this shared sentiment that it's still too hard to build stuff on the cloud, even with the CDK, even with all the stuff that we've been doing. There's still friction. This feeling about the right tool is still kind of something is not really. And it doesn't matter if you're using CDK or Terraform or Pulumi or serverless or Kubernetes or whatever stack you're using. And I've seen like companies approach this in so many different directions. Like Amazon has this like very full stack engineering mode where a developer owns the entire stack end to end, back to back, from the VPC all the way to the operational story. But then some companies have like a dedicated platform team, and the platform team builds a platform so application developers can build their cloud application. Or sometimes they would like sprinkle DevOps engineers in every team so that they have support for DevOps and application developers are able to actually like build stuff. Or sometimes they go and educate everybody, right? Like it doesn't matter if it's like horizontal or vertical or as a platform, as a framework. Like every different combination is still full of friction in a sense. And more I've been thinking about, how can we solve this problem? Like what's the ingredients of the solution? Is like why aren't we solving this problem anymore? And kind of came up with some interesting ideas, and I'm not able to share all of them right now, but I think like the strongest sentiment is that, again, we're missing tools. We don't have the right tools, and we're thinking about this cloud as this big computer, but we really don't have a good way to build applications for this big computer. Like the tools that we're using to build applications for this computer are tools that are designed for the old computers. And so I think a lot of the friction that we're seeing is because we're taking all these tools and we need to like compose them and stitch them together all the time in order to be able to deliver applications to the cloud. And so this friction, when we need to connect all these components together, this is the friction that we experience in the cloud. And so, started socializing these ideas around, and kind of got some backwind from some angel investors, and like kind of like the classic story, and decided to start Monada to solve these problems, right? Like to basically try and make the cloud easier to use, more democratic in that technologically democratic sense, where it's accessible to more people. It doesn't require people learning about all of the layers of the technology in order to use them. We've raised some money, started a company, met with my co-founder who re-met with my co-founder, who is someone that I worked with at Microsoft. It's awesome person. And we're just getting started. So it's like a very young company. It's basically a month old now, a month and a little. And I'm doing something very different now. Like I feel like I'm completely stepping out of my comfort zone. But it's very exciting because I feel like this very similar feeling I felt when we started the CDK is this like internal drive to go and solve this problem, and excitement about some of the ideas that we have, and also excitement about learning how to do this thing, how to like use businesses and corporate and companies in order to solve problems. I've been mostly using software to solve problems so far, and so now I'm kind of expanding myself and doing it from like this internal drive to try and actually make a little dent in how we're building stuff on the cloud.
Yeah, so you mentioned that this was 5 years ago that the CDK journey started for you. 5 years ago, did you imagine that there would be an online virtual conference for the product, or did you expect to see potential competitors like Pulumi and Terraform embracing your product and actually building around it?
I think in my wildest dreams, probably. I mean, I could definitely see the potential back then, because I really saw how powerful the programming model is. Constructs are like we started the CDK after using it internally, like a similar programming model internally, and so like as at first, firsthand, I saw the power, and so I could imagine how powerful it is. I knew how powerful it is. But seeing this community, I think, and I always say, I think like that's to me the biggest win, like because this community was built with almost zero external energy. It was like literally created from like bottom up, people just enjoying the product, believing in the power that it brings, embracing the open source culture behind it, the open ecosystem that we've created with constructs, the stuff that Pulumi's been doing and Terraform been doing. I've never seen Pulumi and Terraform as competitors to the CDK. I know that they have probably, Amazon building this thing, and like, so maybe I had the privilege of not needing to like see them as competitors, but I totally saw these are two different layers, like the provisioning layer and the abstraction layer of the cloud. They're not the same thing. I think the abstractions are, these constructs that we've created, the abstractions are, they have their own life, and they don't need to be coupled with how you're actually installing your thing on the cloud. And I think like there's definitely room for many tools for provisioning, and I think like we see value in each one of those tools, and we see use cases for each one of those tools. And I love it that Pulumi are embracing constructs as a programming model, and I hope that these ecosystems will fully merge. I know that Pulumi still has their component model, and they've done some really awesome built some really awesome technology there. I'd love to see more of like Pulumi being part of that ecosystem and technological ecosystem as well, contributing to JSII and constructs and publishing construct libraries. I think like there's a lot there there's an amazing team there. I've been interacting with them throughout the years. When they released Pulumi, I was like, someone stole my brain. Like I really felt this is like this amazing situation where the two completely disparate teams that are building that have the exact same mental model. And I think like we're still in the same place. Like I still think we're sharing this vision together, and there's so much more to do and so much more stuff to be built in the cloud, and that the cloud is not finished. Like this is not the end game. This is not how we're going to build stuff in the cloud in the next millennia, probably.
Yeah. So you brought up something that I've been dying to ask you, the JSII. Which came first, JSII or the CDK?
So JSII was a result of a review we had with Ken Exner, who leads the AWS developer tools. When we presented him the idea of the CDK, it was actually called IIC, we called it. Infrastructure is software. And it's infrastructure is code. That was like the code name back then. And I remember sitting in the cafeteria after the review with Mitch Garnett, who's a P at Amazon, who've been kind of like helped me bring this to life in the first really, really early stages. And we've been sitting in the cafeteria, and one of the feedbacks from the review was like, hey guys, we can't build this in a single language. Like we support all these programming languages for the SDK, and it doesn't make sense to like require developers to learn a whole new language just in order to use this new SDK, basically. And so we need a solution that would be kind of like the SDK, right? And that's when basically JSII came to life. It's like, okay, we need to solve this problem. And we just like sat there. It's like, if you think about it, JSII, the architecture of JSII is very similar to the architecture of the SDK. Contrary to what people think, JSII is not transpiling code between languages. JSII is, in a sense, it's basically a client that's generated from the type information of the TypeScript module. So we're generating a client very similar to the client we're generating for the SDK, only that the calls to the client are just closed internally on the same machine. And so if you think about it from an architectural perspective, it's basically a client-server architecture. We spin up a node process under the hood that runs the actual JavaScript code. And then every call that we make on the API surface, which is, calling methods, get and set, everything that you can do with a class, basically, just gets proxied down to that little node process through a pipe. And so this is exactly how SDKs work, right? Like it's the client-server architecture. So the only difference is that SDKs go through HTTP and operator and there's operations and shapes and like a different style of API. So we basically created this object-oriented surface area specification, which is what JSII is for all intents and purposes. And it felt like it's a very big hack, but it mostly works pretty well, I have to say. Like I'm shocked every time I see an issue in the CDK repo that comes from a non-TypeScript player. It's like, oh my God, it's actually people using this in production.
Indeed. So you had mentioned in the foreword for the CDK book 4 different directions for the CDK to sort of go: north, south, east, west, up, down, left, right, I think. We've seen those directions, really key off a lot today, and especially with how Pulumi and CDKs, Eli's talk about CDKs, I thought was really interesting. This concept of, you've got this code written in CDKs constructs that's leveraging AWS constructs to build Kubernetes resources that go and build AWS resources. So you've got this incredible, very Inception-like levels of deepness and things. Is there anything about those directions that maybe you've thought about a little bit more in the 6 months since the book came out that you'd like to expand upon at all?
Yeah, I mean, I think this down direction got a lot of energy in the past few months. I think it's all thanks to this service that CloudFormation released called Cloud Control API, which is basically a uniform resource, uniform resource API for AWS. And in that sense, it allows an engine like Terraform or Pulumi or Kubernetes to create, update, delete, list, read, basically every resource on AWS using the same set of HTTP calls, in a sense. And the semantic is the semantic of CloudFormation. And so now that we have this unified API, unified backend API, then it basically decouples the CloudFormation resource specification, which is what the AWS CDK is based on, right? Like the L2's are producing these resources in that with these semantics, and the actual provisioning engine, right? Because the provisioning engine can now speak, every provisioning engine can now speak the CloudFormation language, in a sense. And so this has been an incredible catalyst for this down direction. I've been talking to CloudFormation about this, 2 years ago. They've been into building this for a long time. They've seen how powerful this could be, and how this could be an enabler for other provisioning engines. And I love this about Amazon. Like Amazon is truly customer obsessed in that sense, because you would imagine is like, why would CloudFormation enable Pulumi or enable Terraform? Aren't they competing with each other? And I think like in Amazon, it's and it's not just fluff in that sense. Like in Amazon, if it's the right thing for customers, they will do it. And I think this is a great example of it. Like, yeah, like if Amazon customers have a better way that they want to provision Amazon resources on AWS, by all means, provision those resources. As far as AWS is concerned, this is like the big picture.
Right.
So I love how this happened. So this down direction, definitely. I know. Are we out of time? Sounds like.
Yeah, we are running out of time. We do need to go on to the next talk. I wish we could talk, for another half hour. It's been great catching up with you.
I'll just finish about the vision. Is that I think all of those directions are getting attention, which is beautiful and exciting. And maybe next CDK day we can explore what happened with the rest.
Fantastic. Well, thank you again for joining us today. We really appreciate being able to catch up with you again. We hope to continue to see you here in the community and elsewhere, and can't wait to see what you move on from here.
Thank you, guys. See you later.
Thanks, Elad. All right, so we are going to go ahead and get started right into the next video. We've got Aaron Brighton. This is going to be a recorded video, so no live speakers this time. If you're over in the CDK Dev Slack, go ahead and hop over there. If you've got questions, I'll see if Aaron can join us and get those answered, but we'll get started.
Hello, everyone. I'm very excited to be able to share some of my love for AWS CDK with you today. My name is Aaron Brighton. I've been building on AWS both professionally and as a personal enthusiast for roughly 6 years now. Like many, I was skeptical of using a higher level programming language to implement infrastructure as code. However, for the past year and a half, I've been almost exclusively using CDK for building on AWS. One of the concepts or features of CDK that, in my opinion, drastically speeds up engineering velocity is constructs. These constructs are abstractions of underlying CloudFormation resources with common wiring and sensible defaults handled for you under the hood automatically. This allows an engineer to quickly get up and running with AWS services and build a coherent application that benefits from the power of the cloud faster than ever before. What used to involve hundreds of lines of CloudFormation and hours of documentation reading can now be done in minutes with just a few lines of code. This is the power of constructs in AWS CDK. In this talk, I'm going to introduce the value of building custom CDK constructs and how you can fill the gaps by leveraging CDK custom resources. So what is a custom construct library? One of the fundamentals of CDK is the concept of constructs. For many of you already working with CDK, this may be review. For those new to CDK, I hope this explanation will provide some clarity. In CDK, you have different types of constructs that provide varying levels of abstraction. The lowest level you'll likely find yourself working with are level 1 constructs. These represent one-to-one mappings to underlying CloudFormation resources. No abstraction is provided. This example here isn't CDK code, but it shows you the level of verbosity you'd be working with and the undifferentiated heavy lifting you have to deal with when using level 1 constructs. Typically, you'll be working with level 2 constructs. This is where you first unlock those velocity gains I was mentioning. Level 2 constructs represent one or more level 1 constructs with helper functions that make wiring together resources drastically simpler. For example, the previous CloudFormation template could be trimmed down from more than 300 lines to just 25 lines of CDK using the native level 2 constructs. And finally, you have level 3 constructs. Typically, when you're building a custom construct library, you'll find yourself creating a level 3 construct. As you can probably guess, a level 3 construct is made up of level 2 constructs. This construct typically represents a common pattern that your organization may want to reuse in other applications. An example might be a construct that has input properties such as an Amazon Route 53 zone, a domain name, and an error response configuration, like the example here. When an engineer uses this custom construct within a larger CDK application, it allows the engineer to easily create, configure, and deploy a static website front end, abstracting away the configuration and wiring of Route 53, CloudFront, and S3 resources. CDK ships with some level 3 constructs. However, the vast majority of existing ones can be found on Constructs Hub, a central destination for discovering and sharing cloud application design patterns. I'll discuss Constructs Hub in more detail towards the end of this talk. In a moment, I'll show you an example of a custom CDK construct library I built earlier this year. But first, let me introduce some of the tooling that I'll be highlighting during that process. First is Projen, a project generator that has a project type that sets up all the boilerplate for building a custom CDK construct library. Projen also can be leveraged to automatically set up automation in GitHub for Dependabot and publishing your custom CDK constructs in NPM or PyPI, Maven, etc. For those of you unaware, there's a technology called JSII, which is what makes it possible to write CDK code in the most popular languages today. If you write your CDK constructs in TypeScript, you too can leverage JSII to automatically port your custom construct libraries to those other languages. With Projen, you can easily turn this functionality on by setting the publishing options for the language-specific package managers, which I'll show you in the sample construct later in this presentation. In the earlier example of an L3 construct that eases the setup of static site hosting, all of the underlying resources could be provisioned with native CDK L2 and L1 constructs, level 2 and level 1 constructs. However, sometimes you want to integrate external services or non-AWS services into your CDK applications. Earlier this year, I was prototyping an application on ECS, which did not support TLS termination at a load balancer. Because AWS Certificate Manager does not support exporting the private key for public certificates, I had to look elsewhere for automated generation of TLS certs. Let's Encrypt naturally came to mind. CDK custom resources allow you to write the provisioning logic and glue code that's needed to interact with external services such as the Let's Encrypt issuing servers. Let's deep dive into how that process works. This gets a bit complex, however, I do want to give you some understanding of what happens behind the scenes with custom resources. Typically, that provisioning logic and glue code that you as an engineer would write is implemented as an AWS Lambda function. This Lambda function needs to execute logic in response to create, update, and delete operations issued from the CloudFormation engine. Using our Let's Encrypt example, a create operation would need to A, generate a certificate signing request and persist the TLS private key, B, ask the Let's Encrypt issuing service for a DNS verification record, C, insert that DNS record into Route 53, D, wait for Let's Encrypt to issue the TLS certificate, and E, finally persist the TLS issued certificate alongside the private key for retrieval by an application later. So this is something that a custom resource can do for you, and that logic you would end up implementing within a Lambda function. If an unhandled error occurs during that Lambda function execution and it is not handled gracefully or does not return a valid response to CloudFormation, you could run into a situation where a stack hangs for hours until the CloudFormation timeouts kick in. Thankfully, CDK has some additional tooling to mitigate this and simplify the overall process of creating custom resources. CDK has a provider framework that greatly simplifies building CDK custom resources. The custom resource provider framework makes building high-quality custom resources easier and less error-prone. by abstracting away some of the implementation nuances, as well as handling errors and responses in a way that reduces the chance of your CloudFormation stack hanging. You can see here an example of how an AWS Lambda function backing a CDK custom resource has a simpler boilerplate when the provider framework is being used when compared to a traditional CloudFormation custom resource. So enough sample screenshots. Let's see how this comes together in a real-world custom CDK construct library. We'll be expanding on our earlier example of Let's Encrypt. So here, what I'm showing you is a CDK application that will be used to demonstrate how a consumer would use an L3 construct or a custom CDK construct. So in this example, we're using the CDK Let's Encrypt library, which I had built earlier this year and published into the Constructs Hub. Before I explain further, why don't we kick off a deployment of this and let that run in the background. So what you can see here is, as an engineer wanting to use this L3 construct, all you have to do is specify the zone ID of the Route 53 zone that has authority over the domain that you're trying to generate a certificate for. Also provide the domain name for the certificate that you want generated, as well as an email address as that's required by the Let's Encrypt issuing service. So these 5 lines of code here is all you need, thanks to the power of these constructs, to provision a Let's Encrypt certificate and have that certificate persisted into Secrets Manager for an application to end up using later. So while that's provisioning, let's switch into this actual construct library code, and we'll take a deeper dive. So if we look at the actual CDK construct for CDK Let's Encrypt, you can see the interface for those 3 properties that are requested by or that are needed by the construct to be able to do the job of provisioning a Let's Encrypt certificate. And then you can see the actual wiring code that is tying together the L2 constructs within CDK to create this L3 construct that is the CDK Let's Encrypt construct library. So within here, you're seeing the Lambda function that is used to actually do the provisioning of the Let's Encrypt certificate, as well as permissions being assigned to it to allow it to create verification records in Route 53 to confirm ownership of that domain that we're requesting a certificate for. You can also see the CDK provider framework being used to abstract away parts of the custom resource configuration within CDK. If we look at the actual Lambda function code that does the provisioning of the Let's Encrypt certificate, you can see something similar to what was shown in one of the screenshots earlier. You have this switch logic that is being used. In the case of provisioning certificates with Let's Encrypt, the update and create operations in this library are doing essentially the same thing, provisioning a new certificate. One thing you'll notice here as well is taking advantage of that provider framework. I'm not returning anything. I'm not returning any value. I'm letting the framework itself manage the return values that are needed by CloudFormation. If I wasn't using the cloud provider framework, I would have to understand the format that's needed for that return. I would have to, anyway, there'd be more heavy lifting involved than simply throwing down the logic that's needed for provisioning that Let's Encrypt certificate. So let's switch back to our demo app, and we can see if the certificate has been provisioned. So sure enough, we can see that it provisioned successfully here. And one of the outputs, or the output for our stack here, is the ARN of the secret manager secret that is holding the certificates for us. And we can confirm that that certificate actually got generated by querying secrets manager. And sure enough, so there's a certificate. I was just piping the raw PEM formatted certificate out into the OpenSSL utility in Linux. So, and you can see that domain name that was requested is what is actually showing up in that certificate. Another thing to look at in the CDK custom construct library that was created here, the CDK Let's Encrypt construct, is to look at the actual Projen config file. So within Projen, you can see some of the properties that are used to dictate whether this construct is built for other languages and whether it's published to those other languages package managers. So in this case, we're only releasing to NPM, but you can also add easily enough publish to Go or to Maven or to NuGet or to PyPI. And the other thing which I'll bring up in the next sets of slides is Constructs Hub, and Constructs Hub is looking for certain keywords in those published packages. So in this example, you can see AWS CDK is listed as a keyword. So Projen has thrown this in by default, and that's what's needed for Constructs Hub to actually locate these CDK constructs that have been published. There are a significant number of publicly available community-built level 3 CDK constructs, and you can find them on Construct Hub at constructs.dev in your browser. If you're considering building a custom CDK construct, I recommend searching Construct Hub first to see if you're following in someone else's shoes. Construct Hub periodically scans through package managers such as NPM, PyPI, and so on, looking for tags that indicate a package is a CDK construct, and automatically adds it to the Construct Hub index. Wrapping up, I want to leave you with a few thoughts. If you can't easily do something with the existing AWS CDK constructs and you think you might need to build something custom, check Construct Hub first. There's a chance someone else has been in your shoes already. If you do end up deciding to build a custom CDK construct, I highly recommend doing so with Projen, and I hope you'll share the work publicly for others to benefit from. For situations where you want or need to integrate with external services, the Custom Resources Provider Framework in CDK will make your life easier. Take advantage of it. Lastly, I believe custom resources are an extremely powerful tool in the AWS arsenal, and when combined with custom constructs, almost anything is possible in CDK. I hope you found value in what I've shared with you today. Thank you all for your time. Enjoy the rest of CDK Day, and I can't wait to see what you build.
All right, fantastic. So if you've never dealt with custom resources before, really good reference there for you. They are sort of that Swiss Army knife for trying to get things done that perhaps you can't do, as he said, with just the standard stuff. So next up is going to be a talk by Jerome van der Linden. I hope I am saying that name right. Going to be talking about local testing of step functions, which if you've been following anything I've been doing lately, I love step functions. I think they're fantastic. So really looking forward to this one.
Hey everyone, and thanks for joining my session today for this CDK Day 2022. So I'm happy today to talk about the testing of the CDK-defined state machine, step function. So I'm Jerome van der Linden. Just a few words on me. I'm a solution architect for AWS since almost 4 years now, working in Geneva. Before that, I did many things in my previous company, development, architecture, DevOps, and agile coaching, this kind of things. And in my spare time, when I have a bit of spare time, I'm also a father of 3 kids, which is another job. So today we're going to speak about testing CDK-defined step function state machine locally. And we want to automate this. So we want to start from a CDK-defined step function, so with some code. We want to test it locally, and we want to automate as much as possible this. So this is the big picture. As you can see, we can see step function local, we can see CDK CLI, obviously. But yeah, I won't go into the detail for now, because there are multiple pieces for this puzzle, and I will explain each piece in this presentation. First piece of the puzzle is the CDK-defined step function, state machine. So as you can see, we have some simple code with, here it's TypeScript. So we define the different branches, the different states of our state machine here, just like normal. Then we define the state machine itself, so giving it the definition string, the definition of our state machine, and yeah, that's it. So if we have a look at the workflow, it should look like this, but yeah, it doesn't really matter. It's just for you to see what it looks like, the different states and so on. What is important, however, is this. We will need the state machine definition in the ASL format, the Amazon State Language format, so in JSON. So we need to retrieve this. Unfortunately, with the high-level construct of the CDK state machine, we cannot get it simply. So we need to cast this this state machine in a CloudFormation state machine, and then we can retrieve the definition string and get this definition in JSON in the ASL format. We put it in output, so we will be able to retrieve the output, and I will show you it now. So we use the CDK CLI here, and we need to deploy the stack, unfortunately, to retrieve the output. So we need to deploy it, but with a specific command, so with the -o, and specify the output file, where all the outputs will be stored. So we deploy with this option, and it will actually deploy the stack on your account, on your AWS account, and it will also output this JSON file. I put it in the CDK out folder, because this is the temporary folder where CDK is working. So here we have the file, the CDK, the output JSON file, and we can see the different outputs. So here we have one output for the workflow itself, for the definition string, and one output for an API gateway. So here the one which is interesting for us is the first one. So to retrieve it, there is different things to see. The first one is the stack name. So we have the stack name. When we deploy the CDK code, we have the stack name. Then we have the construct name. So I use a construct to define my workflow and different states and different Lambda function and so on. So everything is in a construct, which is called workflow in my case. Then I have the output name. So this is the name I configured in the code previously. So this is the output name of this JSON string I wanted. And then we have a randomly generated string, which is a bit boring actually to retrieve the output, but we'll see that it's possible to get it anyway. So to do so, we leverage JQ. So we have a wonderful command line here. JQ is, you probably know it. It's a a JSON processor for the command line, and it's really powerful. So we can actually extract the piece of the output that interesting us, and this is the state machine definition in JSON. So we use JQ, which is quite powerful, and we retrieve this this file, so the state machine asl.json. And yeah, as you can see, this is a standard ASL JSON file. So cool. If we wrap up this first step, so we have our CDK-defined step function. We use the CDK CLI and a specific option to get the output, so to get the definition string of our state machine. And then with that, we're able to extract the state machine definition in the good format. We actually need this format because later on we'll see that when you create the state machine, you need the ASL format. So, second step, we want to test locally. So in order to test locally, we don't want to reach out to the cloud when calling our state machine, when executing our state machine. So we need to mock this, this services integration. So it has been announced by AWS in January this year. We are able to mock services integration. So if you have a, if you are calling a Lambda function, if you are looking for data in a DynamoDB table, if you are anything, you can actually mock this services integration so that you will be able to test your workflow, to test the different states, and see if everything works as expected. And you can actually mock the services response. So how to do that? We define a mock config file in which we have the state machine name. We'll see later that it will be important to have it. It's a part of the puzzle. So we need to have the state machine name. We define different test cases. So here I'm just defining an API path, but you can define as many test cases as you wish. And in each test case, you need to mock some states. So you can mock the states you want. If you don't mock them, step function will actually perform a call on the cloud. So you need to mock all the states that are important. So here we have the mocked states. And for each state, we specify the response name. So the response name which make reference to these responses after with the definition. So as you can see, we define the return of the different integration. So here, for example, I'm having a Lambda function that will return some data for the extraction of the information, for example. And you define the different mocks, different mock response for each state that you wish to mock. So this file is really important. Then we have step function local. So this is the heart of the thing we are trying to build in order to start or test locally. So with step function local, here I'm using the Docker image. There is also a jar file for Java if you prefer, if you don't want to use Docker. So here I'm using Docker. I'm starting the step function local image. And something which is important is this mocked configuration. So we specify in this environment variable the sfn mock config. We specify the mock config file we just created. So it will be used by step function to actually return these responses, these mock responses, instead of calling the actual AWS services. Then, once step function local is running, we can create our step function state machine. So we are using the AWS CLI. And we use the step function create state machine command. So we create it with an endpoint local. Obviously, we want to do it to test locally. And we specify the definition that we retrieve in the beginning. So from our CDK-defined state machine, we retrieve this ASL file and we give it here. So we are creating the exact same state machine here locally versus the one we deployed previously on the cloud. So this one will be used for our local testing. And another important point is the state machine name. So as you can see, this is the exact same name as the one we defined in the mock config file previously. So that's why I said it is really important that the pieces of the puzzle, we need to get the same name in order for step function local to be able to retrieve the proper mock configuration in this config file. So, small wrap up, we have our mock configuration, so step function will be able to mock the different services integration. We are also able to run step function local with the state machine with this mock configuration, and we are also able to create our state machine thanks to the state machine definition that we retrieve in the first steps. Now we actually want to test. So we are coming to the unit test, and this is the important part. So here we have our test code, or actually a bit of boilerplate code, where we do different things to initialize the AWS SDK, because we will use the AWS SDK to perform operations. So we use the state machine name previously defined, so the same as in the mock config file. We obviously want to perform our SDK calls locally. So once again, we define this step function client and use the local endpoint. And then we have two methods. We have one method to start the execution of the workflow. Something really important here is that in the IRN of the state machine, we specify a hash and the name of the test case. So if you remember in the mock config file.json, I had an API path, for example. So here we need to specify this in the IRN so that when we will execute the state machine, he will know that he needs to use those specific mocks, those specific mocks when running the state machine. So this is really important. And also, as you can see in the comment, we, for the moment, we cannot execute synchronous express workflow locally because it adds a sync previous to the, it prefixes the localhost with a sync string, and then we have an error. Obviously, the network is doesn't find the sync localhost, so we have an error. So as of now, it's not possible to execute synchronous step function state machine locally. There is, I think, an issue, and at some point it should be working, but it's not possible for now. So in order to retrieve the result of our state machine, we need to use another command, which is the describe execution. And so we have here another method that will retrieve the result and the status of the execution with the describe execution command. And same thing, you cannot describe the execution of an express workflow. So you actually need to create a standard workflow locally. Even if the one you deploy on the AWS is an express workflow, locally, in order to perform your test, you need to have a standard workflow. So hopefully at some point it will be fixed and we will be able to have synchronous and express workflow locally. So yeah, that's to prepare our test. And then in order to test, we can write our tests. So here, two simple tests, one happy pass and the other to test another pass in the workflow. And as you can see, so we retrieve an event. That we will inject into our state machine execution. And we have this start execution and the famous test case name that we want to use. So this is the same as the mock config file. This is the one we use after the hash in the array. So here we have simple test, just verifying that we have a specific result, a small JSON result, and status succeed. You can obviously have a more complex result, more complex JSON, and you can also use another API, which is the describe execution, that will give you more information about the different states. So if you want to go deeper in your test and get details on the different states, it is also possible. But yeah, it was just as a sample here to show you how we can test with the SDK locally. Finally, you run your test, you get your result, you are happy. And that's pretty cool. So if we wrap up the different pieces of the puzzle put together, we first retrieved the state machine ASL from the CDK code. So starting from CDK code in TypeScript, Python, whatever the language you prefer, we retrieve the state machine ASL in JSON. If you don't use CDK code, obviously you can directly work with the ASL, but we are at the CDK Day, so we're speaking about CDK. Next step is to create the mock configuration, to mock the service integration, and to be able to test locally without reaching out to the cloud. So here it is. Then with step function local, so we started with this mock configuration. And while running, we are able to create a state machine locally. So we create the state machine. And finally, we are able to perform our test. So we use the AWS SDK to make calls, to execute the state machine, to retrieve information about the state machine. So everything with the AWS SDK on the local endpoint. And voila, we have completed our puzzle. So yeah, you need to be careful with the different pieces, with the different names, because yeah, you need to get the exact same names in the config file and when you start your function and so on and so forth. So be careful of this. And I give you some resources. So yeah, links to the documentation, obviously, to the blog post for the announce of the mock configuration. And important one, the last one, which is a sample I did for a blog post, for another blog post, but that contains a make file. And in this make file, there are all the commands I shown. You can also see in this GitHub repository, you can also see the different parts, the mock config, the test, and so on and so forth. So yeah, go to this link and you will be able to find everything I presented here. Thank you for your attention. I hope it was useful. And if you have any question, please reach out to me on Twitter or LinkedIn. I will be happy to discuss with you. And yeah, enjoy your CDK day. Bye bye.
All right, so good talk there from Jerome on step functions and how to leverage them for local testing. It's been an interesting story with step functions over the course of the last year. It originally was created years ago, and it was a very narrow niche market for how you could use it. There just weren't a lot of great use cases. And then they did a couple of major releases last year between the UI studio that really leveraged a good framework or a good method for building out these things, and then they added in all of the SDK API support. So then all of a sudden, if you were building these systems, these workflows that needed to interact with existing AWS services, so you're transcoding media, you're processing S3 buckets, you got data pipelines, things like that. It was a great tool for going forward on it. We're using it at my company for doing a lot of built-in automations for our customers. In fact, we trigger them by Slack bots now, so we can go out, allow our customer to just hit a / command in Slack, and it kicks off a workflow that does all this, fancy stuff, whatever it may need to be. And then when it's all done, they just get a message back in Slack, and it's worked out to be really well. We're really good. So our next speaker is Michael Liendo. It looks like he might be running a couple of minutes behind. So I'm just going to chat with you for a few moments. I asked, how are some of our existing users out there watching the stream today? How are you using step functions if you are using step functions? Looks like Aaron's mentioning using step functions for orchestrating a lot of work. Generalized workflow management with Express helping with distributed systems and cutting down on some of the point-to-point management. Definitely, there was a lot that we did originally with Lambda functions that was sort of just these little glue pieces between systems, and step functions has made it a lot easier to replace those things with some existing or some step function work, which has better observability, better replayability, and things like that all along the way. We'll give Mr. Liendo here a couple more minutes to show up. In the meantime, if you've got any questions for us regarding CDK Day, please hit them up there in either the YouTube chat, or you can chat with us over in cdk.dev. We'll be glad to talk with you over there. Also, what has been your favorite part? Have you had a favorite talk so far in either this channel or some of the other channels? What has been, either eye-opening for you or something where you learned something new? Let us know and tell us what that is. So this afternoon, we're going to continue on with some talks around data pipelines, around transitioning from CloudFormation to the CDK, and some personal experiences there. We've actually got two interesting back-to-back talks, one talking about CloudFormation to the CDK, and the one that talks about going from SAM, the server application model, I believe is what it stands for, to the CDK. So, more people transitioning, more support there. And then a very, very interesting talk a little bit later around CDK-web, which is this very interesting, I would say probably POC, I guess, of how you can define your CDK infrastructure in a sort of web HTML friendly way. So very interesting there. Seeing if we can, where is Mr. Liendo today? Okay, so it looks like we may have a time zone issue. So let's see here. Give me one moment here. Tell you what, it looks like we do have a little bit of confusion over some time slots for now. So tell you what, we're just going to put up a banner here on track 1. If you want to head over to track 2 and check out any of the talks over there, or track 3, I'll provide some links here in the chat. So over on track 2 right now, we're having a wrap up on a panel discussion of the local cloud, ideas to ensure the developer productivity. We also just wrapped up over there on stream 3 some hybrid CDK Terraform constructs. So it looks like best place to head over to right now is track 2. So let me get you a link for that one. I'm going to go ahead and paste in the chat, and you can head over there for now. Blake Green, show us your Slack step functions. Oh, I would love to. If it wasn't proprietary code for a client that I cannot actually share on screen, I would be glad to show you. But in essence, kind of the general workflow, I can walk through it real quick, is I put out a Lambda function. I use the brand new function URL feature of Lambda to give myself a nice, easy to use endpoint with that. And then registered that in our Slack API as a / command. That Lambda function then takes that request from the Slack bot, parses it out, and then determines which environment to go connect to. So it assumes a role or assumes another role into another account, and then starts the step function execution, handing over the basic parameters for the step function as well as the Slack callback URL. So that is now going to go and run a step function, make some various API calls and other things, and then respond back to Slack. We actually had an interesting request come in from the client saying, hey, Slack is great, but we also want to make this part of our API application automation testing. So they wanted a publicly accessible API to do this with. Unfortunately, though, there's no way to retrofit a Slackbot webhook to easily work with just sort of a generic API call. So what we're going to do is, let's see here. Okay. Sorry, catching up on the time zone confusion with our speaker. So what we're going to do here is actually take this step function, take the small portion of it that runs sort of the business logic, and pull that out into a new step function. The original step function will call that step function and keep the Slackish components involved with it. But then we got a whole nother step function over here that is purely the business logic of the call. Put another Lambda with a function URL in front of that. And now we have this sort of nice shared business logic between either a more human callable API or a Slackbot callable API. And hopefully that will work out well. So we are going to shift up the schedules a little bit. It looks like Mr. Liendo is going to be coming back to us later. So let's go ahead and we're going to actually run a quiz right now. So what I'd like you to do is I'm going to go ahead and provide a link here in the chat. Actually, better yet, we're going to use a banner. So what I'd like you to do is head over to menti.com. We're going to have a little fun with a quiz, see how much you guys know about the CDK. So head over to menti.com. I'll give you a couple minutes to get over there. And when you get there, enter in code 10714220. Once we start to see a couple of people pop in there. All right, we've got a couple people in, 7 people in so far. We'll give everyone a couple minutes to join in. Now, we're going to see how well this works. We've never really used this before. I've never used this before, seen it a few times, but hopefully kind of a fun way to engage real quick and see how everyone's doing with their CDK knowledge. If this all blows up horribly, well, hey, isn't that the fun of doing a live demo? All right, we'll give everyone about just another minute or two. We got people popping in left and right. Yes, thank you, Michael. Yes, the fun of doing a live conference, having to pivot out of nowhere. All right, so let's get started here. We got a few people joined in so far. All right, so first question up. The faster you answer, the better. What does the CDK stand for? What does the CDK stand for? Is it the Construct Development Kit? Is it the Cloud Development Kit? Or is it the Can't Do Karate? All right. Most of you got that right. We've got the Cloud Development Kit. I actually, when I first saw it, I thought Construct Development Kit would work better. Nobody was fooled by my can't do karate quiz. So good on you. All right, next up. When was the first public release of the CDK? Was it in June 2018? Was it in July 2018? Or was it in July 2019? All right, so we got leaning towards the June 2018 right now. Oh, July 2018 just caught right back up. A little bit on the July 2019. Okay. We'll wait till this settles down for a moment. All right, that looks like that's probably about it. So the correct answer is, that's right, July 2018 was when the CDK was the very first initial release here. Oh, it looks like not everybody had answered, so went a little early. Okay. Moving along, when did 1.0 release? So maybe a little bit of a trick here. You know, the first public release of the CDK was not 1.0. It was, I think, 0.8 was the official release. So when was the 1.0 release of the CDK? Was it July 11th, 2019? Was it July 13th, 2019? Or was it July 31st, 2019? All right, so pretty even here, you know, July 11th, taking the lead so far. July 13th, you know, real quick, no cheating, by the way. You're not allowed to go over to the GitHub page and look at the releases. I mean, that's how I found out, but you're not allowed to do that because that wouldn't be any fun. Ooh, complete even split right now. Oh, July 13th just took the lead again. All right. Give it a few more minutes for responses, a few more seconds for some responses. Looks like that's about everybody. So the correct date is July 11th. It was July 11th, 2019 that the 1.0 release initially hit. All right. Now this is a completely open-ended question. Feel free to put in whatever answer you want to here. What is your favorite construct? What's the construct that you think is like the coolest, the most useful, the one that you use the most? What is it that you've got that you do the most of? Just go ahead and type in whatever answer you want. This is a question. I don't know exactly how this quiz question is going to work out, so we'll see. So far, nobody has responded, so maybe it's not working at all. Event bus. Okay, so we got event bus is a popular one. ECS with load balancer. Yes, I think yeah. The answer was ESC that was put in, but I think ECS was what was intended. Definitely, I've been using that one for a client lately. Definitely like it. For the ECS with a load balancer. Really get a nice full-on L3 package there. The bucket, yep, definitely. S3 buckets, the Node.js function. That's a popular one. We've also got CDK pipelines. Yes, so the CDK pipelines, if you're writing CDK code, you should probably be using the pipelines construct. That's what gives you that CI/CD through code pipeline to, you know, get your code deployed out in a nice CI/CD fashion, because, you know, we're treating infrastructure as code, so we should be deploying it like we deploy normal application code with a nice automated pipeline and everything. So, you know, I'm supposed to mark one of these as a favorite. I can't really say. API gateway, also a good answer there too. So we'll just go ahead and say event bus is the winner, and we'll move on. All right, so question 2 of 5. Interesting that they the numbering on this is weird. So next question. Faster answers do get you more points along the way. When is the CDK 1.0 being deprecated? When does it hit end of life? When are they putting it into support mode? Is that June 1st? Is that July 1st or is that August 1st? And that's all this year. If you were listening earlier to Rico's talk, you will probably have heard the date on there. It is going into deprecation June 1st. So we are just days away from when they will not be doing any more major feature changes to 1.0, and you really do need to try to be on 2.0 as soon as possible there. The migration is fairly easy. There are good documents online, and if you're having problems, we have a channel dedicated over in our cdk.dev Slack server for any questions around that migration. All right, next one. Again, faster you answer, the more points you get. So, when did the CDK v2 get general availability? When was v2 officially released and no longer in preview mode? Was that June 1st of 2021? Was that December 2nd of 2021? Or was that January 13th of 2022? Very good. Yes, it was December 2nd, 2021. It was actually during the Werner's keynote at reInvent 2021. He got up there and you mentioned that V2 had gone into GA. Actually, there was a little bit of a mix up there. It was originally said that it was in preview, I believe it was. It had been in preview for months, and it was officially GA at that point. So I guess maybe a little bit of a trick question there if you were really getting technical. All right, next one. The pipelines.code pipeline can deploy cross-account, true or false? Can code pipeline, that L3 third-party construct I mentioned, can that deploy across AWS accounts? True or false? That is true. You can very easily set up those code pipelines to deploy your CDK code across multiple accounts. So if you are using a setup where you have, say, like your dev account, your staging account, your production account, and you've got your management account, which pushes to all of those environments, Code Pipeline pretty much handles that with just a small configuration of what that account number is. Very easy to use, very convenient there. All right, and our last question, 5 out of 5. What resource cannot be hot swapped? So what resource cannot be hot swapped with a recently introduced hot swap flag? Is it AppSync mapping templates, Lambda functions, state machine definitions, API gateway configurations, code build projects, or ECS services? I thought this one might catch a few people. So the hot swap is a brand new feature. They just released it, I believe, a couple of months ago, and it really helps with that development pipeline. You can hot swap your Lambda functions. That was the first thing that they released. State machine definitions came pretty quickly after that. And since then, you can now hot swap your AppSync mapping templates, your code build project definitions, and even ECS services. API gateways are the only things that in this list you cannot hot swap at this point, but who knows, maybe that'll change in the future. If you wanted to, open up an issue over at their GitHub page and request that, and hopefully we can see that go in the future. But all of those things can be hot swapped. Definitely speeds up sort of your development process as you're going through and trying things out. You're working with your dev account, but remember, hot swapping is not for production. If you want to speed up your production deploys, I recommend you go back and watch Ken Winter's talk just a few moments ago, where he talked about really being able to deploy, a good deploy all of his stacks out using a nice parallel deploy in GithubActions and that sort of thing. So let's see who got the best out of the best. All right, so it looks like Lance from Iowa, USA, you got first place with 3,671 points. Congratulations. Second place and very close behind, we had JD. I'm gonna probably butcher this name and I apologize, Ludovic. Looks like we also got Oliver all of you came in real close there, real close, first, second, third, and fourth place there. So hopefully that was at least fun and somewhat entertaining for a couple of minutes, and fun quiz. So you can go ahead and close that down. We are all done there. So looking at our schedule today, we've already hit quite a few talks. We've talked about a lot of good stuff, the Pulumi stuff, the CDK's functionality, really interesting seeing how those things are really taking constructs that you've been working with and letting you change out how you really deploy those out into an environment, whether it be through Terraform or through the ACK module that is new within Kubernetes. And we saw Ken talking about his parallel deployments. We got to see those kind of fun GitHub actions and how he's really leveraging Projen to take a look at the CDK code that gets generated and then use that to define his GitHub workflows. If you haven't had a chance to explore Projen yet, Projen is this really great system that came out of the CDK work that takes this idea of constructs that we've all grown very familiar with and applies them to any file within your repository. So not just CDK related, this can handle Python project code, Java code, can handle GitHub workflow definitions, GitLab definitions. Pretty much if it's a file in your repository, Projen can manage the contents of that file in a programmatic way. And this gets very, very useful when you're talking about either trying to generate those contents from other things, like what Ken was doing of generating a GitHub action file from what the CDK generated. Or if you're talking about, say, you've got a large organization that has standardized on microservices. So because you've got microservices, you're probably going to have a lot of them. And every time you have a new microservice, you probably have a new Git repository for it. And for each of those repositories, you need to have your standard company setup of git ignore contents, GitHub action workflows, ESLint settings. Maybe you've got a requirements.txt, maybe you've got linters, these things that become standardized. And boilerplate and templating code was, fairly good for a while in being able to, start and bootstrap up a repository. But, 6 months down the road, if that bootstrapping template changed, there isn't really a way to, reapply those changes. Projen really steps in for that gap, and a very, very useful tool. We've made it standard at my company for all of our clients, and we've seen a lot of really good value come out of that. And very cool seeing sort of that interop between the CDK and Projen there with his talk. We got to catch up with Elad. If you aren't familiar, Elad is the creator of the CDK. He started the project and managed it for many years at AWS. He did leave and decided to go out on his own adventure back, I think, in January or February of this year. But as he mentioned in our talk earlier, the CDK is in great hands. There's a lot of still fantastic people who are there chugging away on producing really good code, still doing weekly releases and things like that. But, as Rico mentioned during the keynote, this is something that AWS really is, while they may be trying to be the stewards of the product, they are looking for contributions from the community, and those contributions can be new L2 constructs that might be missing. They might be enhancements to the existing L2 constructs. Maybe there's an L3 that you have built as a third-party construct and published up on the Constructs Hub. Consider opening up a PR and getting that into the upstream of AWS CDK and allow everyone to benefit from that just out of the box, which would be great. Documentation is always a place where every open source project can always benefit from good documentation and help from the community there. So if you've been reading through the documents of the CDK and you read through a part and you think, well, that is a little bit confusing, or I think this could be worded differently, definitely go and submit a PR. There is a very extensive and good contributing doc in the repo that explains exactly how to go through. There have been numerous videos from the community on how to do development work within the CDK, and I highly suggest, if you want to see the CDK product continue to grow and continue to be useful, consider contributing to it yourself. That'll definitely help out a lot. Aaron Brighton did talk about those custom resource constructs. So one of the things that CloudFormation is very good at is handling the management of resources that they've predefined. But of course, as we've seen, CloudFormation doesn't always get support for things right away for developing new resources as AWS releases them, new services. Maybe it doesn't show up in CloudFormation right away. Maybe there's something you want to do like what Aaron was doing, where you don't even use AWS, but you still want to manage that resource through infrastructure as code and through that same provisioning pipeline of CloudFormation. And that's where custom resources come in. And the CDK provides not only the normal direct access to those custom resources that there has been for years, but also some really nice sort of L3 constructs for making interaction with those resources much, much easier. One thing that I've done many a times when building custom resources is that I'll write the Lambda function that backs it, and I'll forget or typo or whatever something in that Lambda code. So the custom resource goes and starts building, and the Lambda function fails. Well, if the Lambda function fails, it can't respond back then to CloudFormation to say that the resource either did or didn't provision correctly. And now you've got CloudFormation hung for potentially an hour before it registers, oh, this custom resource never completed, and it tries to roll back and tear everything down. Well, then you have to wait another hour for it to tear it down, and that's a horrible, horrible developer experience. Losing 2 hours out of your day and having to go find something else to do while you're waiting for this thing to fail and roll back is never a good feeling. So, take a look at that AWS custom resource provider. It takes a lot of that legwork over communicating back and forth with CloudFormation out of your hands and makes it a lot easier to deal with. And there's additionally another one that if all you're trying to do is make some AWS API calls, it's even easier. You don't even have to really worry about writing a Lambda function anymore. You just tell it what API call you want to make, and it takes care of that for you. So very cool stuff there. Hopefully also, we've got a lot of stuff going over on the other tracks. There's been some talks over there regarding event-driven architectures with the CDK and how to build those, more stuff around step functions, which again, I love step functions. I love seeing the adoption of it. Testing, one of the things that's really great about the CDK is not only can you unit test it through some basic snapshots or fine-grained assertions, but there's now the integration runner that they've released that allows you to create an example stack and actually deploy that out to a environment and check to see, does the stack deploy? A lot of times, a lot of classifications of bugs, a lot of problems that you may have in your code can be found just by trying to deploy a stack. And now we've got this really easy, nice mechanism to build these things into our automation so that we can deploy out to a sandbox environment, verify that things are working, and then it gets automatically torn down and everything as well. And then I believe there's even a talk, yes, so there's a talk that was over on Stream 3 that happened about an hour and a half ago by Yannick, I believe, Yannick Wempy, talking about integration testing serverless architectures with the CDK, which again takes us now a step further. We had unit testing to begin, really quick feedback cycles, but doesn't really catch a lot of common bugs. And then you've got your integration testing, which is a little bit slower, longer feedback cycle, but gets us to catching more bugs and resolving more issues before they go into production environments. And now we've also got this, let's deploy it out, and now let's run full end-to-end tests on our environment, and let's make sure that everything is working properly end to end, which is sort of the golden standard, the holy grail of testing any sort of environment, and a place where people still very much struggle to this day of really being able to verify, full running environment, does my code work? So very good, very fun stuff there. A lot of good talks today. Hopefully you've all been enjoying them and like what we're seeing. So we are going to go ahead and continue on into our next talk. This one is going to be about data pipelines and how you can build out your CDK code and doing that for these data pipelines along the way. So
would be I got to spend developing data pipelines in CDK, which can be modularized, reused, and through the process I learned a lot of things that I thought would be worth sharing with my fellow CDK users. So so this pipeline that I was developing also had it was event-driven, included monitoring, alerting, version control. So some of the things that I noted down were things that it took a lot of time to discover and troubleshoot. So I hope this is useful for everybody, and without further ado, let's get going. So the first slide I have here is the basic practice architecture, or the best practice architecture that I've used so far. So we all know that the granularity goes from app to stack to constructs, right? So one of the things that I was able to make was to create individual data pipelines for each table. For example, for each table source. Let's say a file lands in S3 and that's intended to be merged with a table or intended to be ETL'd into a table. And that's different from a different table or a different file that lands at a different S3 or like another folder within the same bucket, right? So when this happens, you want a data pipeline that's event-driven. So you're not like setting up timelines, but you're processing the files as they land. But you also want to just construct the data pipeline once and reuse it for the same pattern. And by pattern, I mean file that lands or intended for a specific table. So what I've done here is just write a construct, which is the lowest, finest grain. And this construct has like S3 put notifications, event bridge, notifications that says if the process is complete, Lambda function, SQSs, also the code that goes within the Lambda function. So what happens is from the stack, all I would just send is the file name, and if I have a table primary key, for example, those are the only two things that I would send at the stack level. So the construct would just repeat itself over and over again for each table. So what I was able to achieve by this was I had a pattern for ingesting files into Redshift that takes the same set of steps that can be repeated. But if I get a new table tomorrow, right, for me to set up the entire pipeline and deploy it, it just takes like 4 lines of code, and that only happens at the stack level right there. So that was very useful for me, and I thought that was a good takeaway to modularize and reuse patterns. So in the future, if I was inclined, I could make the construct into a level 3 construct that has the entire pipeline and then share it with the rest of my organization. So they can use it to ingest similar files, for example. So that was one thing that was useful that I think other developers can use. So going into some of the things that were specific was the error text is the first one that I want to talk about. So there were two flavors of errors that I ran into. One of them was the name error, and like the name suggests, it's very straightforward in the sense that you are missing a variable. Like it's so the target is something that doesn't exist, and if it doesn't exist in the sense that while the compile happens, it hasn't read a definition for a variable called target yet. That's what it means. So that was easy to solve. The harder ones were the ones with type errors. So there were two flavors in type errors also. So one was that it just flat out told me what was missing. In this case, in the first case there, it says that the keyword called code is missing. Okay, that was easy. So I need to like understand what needs to be fed into that variable and make sure that that gets filled out. But the second error that you see says that the add target is an unexpected keyword. So that kept throwing me off a little bit, right? Because I knew that I need to send those things inside the add target called the SNS topic and the message that needs to go within the SNS topic. But the problem was I wasn't sure if I was filling out the correct class and the attributes for the class. So for the most part, the way I was able to solve this was to understand if I am A, calling the correct class, B, calling the correct attributes within the class, and C, calling the correct functions within the class. So in this case, the way I had to solve this was to first create an SNS object and then call the send message function within the SNS object, then send the topic and the message within it. So it's a lot of Python, but it's very Pythonic, right? Like you call the class first and then you call the function within the class. But the confusing part is when that needs to be filled in as a function to another class. So in line 32, it's like 4 levels of classes and attributes. So what I would focus on is to like understand the smallest piece is, for example, in this case, like what is the SNS topic that I need to send? Then build on top of that. Okay, now I have the SNS topic, so I call the SNS object and I'm sending the topic for that. Then this needs to be a target to an event bridge. Then I add the add target to the event bridge. So that helped and that worked. It was a little bit of a strange looking at the type errors like that, because it's technically not exactly a type error, meaning which is not a data type error. It's more or less like missing error or incorrect use of a value error. But my takeaway, or the takeaway that I want you to take away from this, is that don't let the word type error trip you. Just make sure that you construct from the smallest element to the largest. That way you can understand and cater to the requirements of CDK. So what that means in this case is first constructing the SNS topic, then adding that as a target to event bridge. So that was one. So this actually leads me to the next slide here, because this is an extension of what I was talking about, right? Like, for example, this is the Lambda function, but just to construct this Lambda function, you need to first write the role, like construct the role, then you need to write the VPC, the subnet, the layers, the security groups, and only then the Lambda can reference all of that. So it's a piece-by-piece construction. So all I want to do was a Lambda function, but to do that, I had to write everything that led up to it. Again, my takeaway for you guys is to take it piece by piece and then construct it like a small Lego block. One of the things that I did here which really helped me was I was using a CI/CD pipeline using GitLab to deploy the same CDK code across multiple AWS accounts. So to facilitate the parameterization across them, I was able to store the parameters in the AWS parameter store, like the account number and some of the values that were changing between the accounts, like the S3 bucket, for example. So I put all of them in the SSM parameter store, so that remained within the AWS account. So when it moved from one environment to the other, all I had to do was just deploy it, in fact, because the SSM would pick up whatever was in that environment. So the code never changed, just the parameter for the CI/CD changed. That's one takeaway from the definition that you can do while writing your CDK code. Next is, this is more a personal philosophy for me, where I found that the level 2 constructs were just perfect for just writing the code and extending it, especially when it came to Python. I do not know a lot about the TypeScript where this was originally written, but with Python, it was a lot easier to just write level 2 constructs because it was at a place where the abstraction was just exactly there, and it wasn't too low level where you had to supply every parameter, or it wasn't at way too high level like a level 3 where you have the whole pipeline for you. So the two things that you see here are between the CFN, which is usually a level 1 construct, and the function, which is a level 2 construct. My personal preference was to take the level 2 constructs. And I did link the constructs page here for Python, and I should say I spent about 95% of my time writing code in these pages, like pouring through them, understanding how the classes and the functions are constructed. It was helpful. So I will leave you with that it was good takeaway for me to understand between different types of constructs that came out of the box with CDK. The other thing I would leave you with is there are more than one way to do the same thing. You could write a policy, like there were cases where this, for example, an IAM policy could be a document or inline. So I would just pick a lane and just go with it. There is no correct answer of how to define this. There's only correct definitions, meaning if you don't supply all the parameters that it needs to exist, the pipeline would be finished. That's about it. The other thing that I walked away with at reInvent last year, 2021, was that new constructs could only be written in TypeScript and exported to Python, which may or may not be the case right now, but I would take that into account if you're writing new either level 2 or level 3 constructs. So just something to keep in mind. Watching my time here. Very good. Moving on. I wanted to bring this to everybody's attention because this is one of those things that I had to fall over to understand what was happening. So in a couple of slides ago, we did see that when constructing a Lambda function, right, you need to write the VPCs first, the code first, and all of the other things must exist before the Lambda can be created, right? So those are explicit dependencies, meaning I need to have them defined first for the Lambda function to exist, meaning otherwise the error would just be apparent, meaning I can't see this, so I'm either going to throw you a type error or a name error. But there are things called non-explicit dependencies. What I mean by that is, let's say you create an SQS in line 5 of your code, right? And you're going to use that SQS in a different part of the pipeline, and say in your CDK code, that's say line 350, for example. The way CDK deploys in CloudFormation is, if it's not explicit, the deployment can happen in any order. So sometimes what I ran into was that the line 350 of the code that was using the SQS would not find it because the SQS wouldn't have been created. So I kept getting an error that says the queue doesn't exist. But it does exist, right? I did create it ahead of time. So one of the things that I personally did to solve that problem was to introduce a wait condition that was just wait until the SQS is created before going through the rest of the steps. It's not the best case scenario, but I would recommend trying that if you have a huge pipeline like I did, which was 4 or 5 steps long, and with 4 or 5 steps, there are like 45 components that need to be created: SQS, S3 buckets, notifications, lambdas, even bridges, SNSs, SQSs, and so on. So I would introduce a wait condition because it helps you to pace it out. So the SQS gets deployed first, and then the rest of it follows. That was a good takeaway from deploying multiple times across multiple environments. This was a fun one. This is not exactly a tip, more likely a trick. So when you're writing the code and you want to see or quickly know if it's fine, if all the parameters are satisfied, I would just do a CDK-ls as opposed to a CDK-diff for a deploy. Only because I've seen that the ls just took lesser time to give me an error as opposed to the diff or deploy in terms of compilation. I know it's not exactly the same. It doesn't work that way. It was just for me to quickly compile the code. And if there are errors, I just want to know it ahead of time before deploys and diffs. I will tell you this, though the errors may not visible while it's doing ls or diff, I have seen cases where the deploy finds errors. Like one of the things was that the SQS wasn't found, right? Like the SQS did not deploy, and then it was getting used in a different part of code, so it just threw me an error saying, hey, I can't find something. That was a deploy level error. There was also access level errors that I ran into when it came to deploy that wasn't found within diff or ls. But for just simple compilation, I would just do CDK-ls because it was just quick to give me a compilation answer. Moving on, I have 2 more slides here, which I think you would enjoy and walk away with. One of them is drift detection. This was very crucial. So let's say, so we all know that CDK deploys through CloudFormation templates, right? So CloudFormation template is aligned. What I mean by that is it only knows what it deployed. It does not know what happens apart from what it deployed. Let's say, for example, I create an S3 bucket, right? Through CDK, and I deployed, perfect, voila, it created. I have a team member who accidentally went into the S3 bucket and changed, say, from a private bucket to a publicly accessible bucket. Now, this is a huge thing, right? It changes the structure of the bucket. It's an infrastructure component that's now changed. But what happens with CDK is that CDK does not know that there has been console changes. So this is called a drift, and CDK does not detect drift. This was a huge problem for me when there were changes made to the console by accident, intentional, malicious, and that were detected by CDK, and CDK was like, there's no problem. I see that it's perfectly deployed. And there were cases where the whole thing was deleted, like an SQS was deleted once. So what I would do in these cases is to restrict access. And the other thing I could do was to destroy and redeploy the templates, deploy the whole stack. The last one is just additional material that I want to leave you guys with that I did not get to explore. And these were just testing. There were unit test cases that I could write within CDK that I did not get a chance to explore more. There were assertions that tests. Maybe this is a place where you can explore those creating things ahead of time conditions, and also using level porting the pipeline that I constructed as a level 3 construct was not something that I did in depth. So I would leave those things in here. Of course, the presentation will be shared for you guys to maybe explore that in the future. But I hope that session was useful. Just a couple of takeaways for something from one engineer to another who learned it in the hard way. And I hope that was useful for you for your journey as a CDK developer. That's it. Hope you had a good time. Talk to you guys later. Thank you.
All right. Well, hopefully it didn't just blast anyone's eardrums. I know that video was a little quiet. We apologize for that. But we'll go ahead and get right into the next one. So this next talk is going to be really about some lessons learned and things going from CloudFormation to the CDK. So there we go.
Hello, thank you for joining this session. My name is Bhuvaneshwari Subramani, work for Infor as the Director of Engineering Operations. I'm also an organizer of AWS User Group Bengaluru and AWS Hero from India since 2019. I'm pretty excited to join hands with Vijay Nirmala and meet you all as part of CDK Day. In this session, we will have a brief overview about infrastructure as a code, AWS CloudFormation, and AWS CDK. We will dive deep into the AWS CDK Adaption for AWS CloudFormation users and review the benefits and best practices for CDK adoption. We will start with infrastructure as code, run through the choices available, and look at the AWS CloudFormation followed by AWS CDK. We will walk you through the steps to migrate the existing infrastructure as a code from CloudFormation templates to AWS CDK. Let's look at infrastructure as code. Assume we have two teams, application development team and infrastructure development team. The application team creates the application. The application developers own the backlog stories and unit tests, and they develop features based on the specified application target. This team's organizational goal is to minimize the time these developers spend on non-core application tasks. Coming back to infrastructure team, they write the code that both creates and configures the infrastructure needed to run the application. This team might use native AWS tools such as AWS CloudFormation or generic tools such as Chef, Puppet, or Ansible. The infrastructure team is responsible for specifying what resources are needed, and it works closely with the application team. The infrastructure team might consist of only one or two people for a small application. In today's fast-paced world, to establish a solid base and take the feature changes to production faster than ever before, continuous integration and continuous delivery should be in place, not just for your application code, but also for your infrastructure code. To track issues and history, we should treat infra code similar to the application code, store them in source control, which could be your Bitbucket or code commit. For every commit, you can build followed by related validation test suites. You may configure pre or post commit hook to validate the code in the source control system. Some of the choices we have for infrastructure as a code are Chef, CloudFormation, Terraform, Pulumi, Puppet, and Ansible. The AWS CloudFormation is a service that helps you to model and set up your AWS resources so that you can spend less time managing those resources and more time focusing on your applications that run in AWS. You create a template that describes all the AWS resources that you will want, like Amazon EC2 instance or Amazon RDS-DB instances. and the CloudFormation takes care of provisioning and configuring those resources for you. You don't need to individually create and configure AWS resources and figure out what is dependent on what. The CloudFormation handles that. CloudFormation template consists of the description, metadata, parameters, mappings, conditions, transforms, resources, and outputs. Except for resources, all sections are optional. The template can take appropriate parameter values and create resources for the respective environment, be it your test or production. For example, your test environment can have very fewer web servers, 2 or 4, and production environments can have 40, 50 web servers based on the need and the traffic that is flowing in. Let's look at AWS CDK. AWS CDK is a software development framework for defining the cloud infrastructure in code and provisioning it through CloudFormation. Remember, you don't create CloudFormation, but the underlying principle or the framework below AWS CDK is the CloudFormation, which is automatically created for you. AWS CDK apps are composed of building blocks known as constructs, which are composed together form stacks and apps. The constructs are the basic building blocks of CDK apps. A construct represents a cloud component that encapsulates everything the AWS CloudFormation needs to create the component. To provision infrastructure resources, all constructs that represents AWS resources must be defined directly or indirectly within the scope of a stack construct. The unit of deployment in AWS CDK is called stack. AWS resources defined within the scope of a stack, either directly or indirectly or provisioned as a single unit here. The standard AWS CDK development workflow is similar to the workflow you are already familiar with as a developer, just with a few extra steps. Here, the first step is to create the app from a template provided by AWS CDK. Next, add the code to the app to create resources within the stack. Then go ahead and build the app. The build step is optional. Even if you forget, the AWS CDK toolkit will do it for you. And the next one is synthesize. This synthesize step will synthesize one or more of your stacks in the app to create AWS CloudFormation template. And the deploy will help you to deploy one or more stacks to your AWS account. So what happens here? The build step catches syntax and type errors. The synthesize step catches logical errors in defining your AWS resources. The deployment permissions would also result. As always, you go back to the code, find the problem, fix it, then build, synthesize, and deploy again. You can use AWS CDK command line interface to interact with your AWS CDK applications. CDK CLI allows you to list the stacks defined in your CDK app. Synthesize the stacks into CloudFormation templates. Determine the differences between running stack instances and the stacks defined in your CDK code, and deploy the stacks into any public AWS region. Next, we'll look at the AWS CDK framework. The AWS CDK supports TypeScript, JavaScript, Python, Java, C#, and .NET. Assume you are planning to define AWS CDK to build two constructs, construct A and construct B, where construct A is defined to create Amazon SQS and Amazon Lambda, and construct B is defined to create Amazon S3 bucket and Amazon DynamoDB table. When you run CDK synth, it compiles your AWS CDK application into AWS CloudFormation template. For deploying the resources into your AWS account, run CDK deploy from the command line, which deploys your AWS CDK application into testing or production via AWS CloudFormation. So here are some of the benefits of adapting AWS CDK. You can build with high-level constructs that automatically provide sensible, secure defaults for your AWS resources, which will help you to define more infrastructure with a very less code. You can use programming idioms like parameters, conditional loops, composition, and inheritance to model your system design from building blocks provided by AWS and others. Remember, the developers use the known programming languages, which comes handy. You can put your infrastructure and application code and configuration all in one place, ensuring that every single milestone you have a complete cloud deployable system. Connect your AWS resources together across stacks and grant permissions using simple intent-oriented APIs. You can import the existing AWS CloudFormation templates to give your resources a CDK API. Ultimately, we're using the power of AWS CloudFormation to perform infrastructure deployments predictably and repeatedly with rollback on error. You'll be able to easily share infrastructure design patterns among teams within your organization or even with the public. Over to Nirmala, who will guide you through the steps involved in migrating AWS CloudFormation template to AWS CDK.
Thank you, Bhuneshwari. Hello, everyone. My name is Vijay Nirmala. I work for Kyndryl as a cloud implementation specialist. I'm a passionate tech blogger, writer, and an AWS community builder from Bengaluru. I welcome you and a big fat thank you for joining us in today's session. Now let's get into the topic. Migrating existing IAC from AWS CloudFormation to AWS CDK. AWS CloudFormation is a service that helps you model and set up your resources so that you can spend less time managing those resources and more time could be spent on focusing your applications that run on top of this infrastructure. CDK is basically allowing us to express the infrastructure using high-level object-oriented code with a team or people who are already familiar in leading programming languages like TypeScript, Python, and Java. Advantages being the same skill set can be utilized for infrastructure creation and maintenance as well. When the actual CDK code is executed, behind the code, one or more of the CFN templates that are created as a result. So when invoking commands, for example, CDK deploy, it's a CloudFormation service that performs the actual provisioning of the AWS resources defined by the CDK code. Since our use case is to explain about migrating from CFN to CDK, we need an existing stack in our AWS account to visualize how CDK gets the code migrated successfully with simple changes. This is an example of a CFN code which will create a VPC, subnets both private and public in this AWS account. The CFN template is applied successfully and those screenshots are shared here. In this example, it is vpc-demo.yaml. Now we are going to name the stack set as migration stack while applying the same in the AWS account. Next, this is the screen where we provide the template with the parameters required like public, private subnet ranges. By this way, we can see how the migration works for a parameterized CloudFormation template and how easily it is handled during the migration to CDK. Successful creation of resources via a CFN template is captured here. This is a view of the CFN stack code under the template section. So this completes our creation of the resources via the CFN templates. Now, in order to create a setup for the CDK usage, let us begin with npm installation in CLI window. We need npm to be installed in order to use CDK for TypeScript. Facts about npm is that it's a node package manager. This is basically a software package manager. It is essential for teams to know about npm to work with CDK. npm is the world's largest known software repository. Basically, the package definitions are written in single file called package.json. Now, let us see how to set the CDK initiation with TypeScript for a new project in CDK TypeScript. TypeScript is fully supported client language for AWS CDK. So this is just about creating a folder setup for a new project or an application that we're developing. This is a structure of package.json. So basically why there is a package.json, or rather what is package.json? This is our NPM manifest. It holds information like name, build scripts, version, dependencies that are required for our application. In order to perform the migration successfully, we need to add a mention of the module CloudFormation include under dependencies section of the package.json. As we could see, this JSON file handles and controls multiple areas like name, version of the application we are migrating currently, scripts that are being used, for example, TSC for TypeScripts, then dev dependencies, which highlights the versions used against each utility like TypeScript, Node.js, etc. And lastly, the CDK dependencies modules, libraries, and the versions of those libraries, etc. Another key and vital feature, which is quite simply listed here, is the watch. This feature will continuously monitor your CDK code or source files for any changes and performs deployment of stacks where any changes are detected. Hence, continuous integration can be implemented with simple configurations to the package.json file. This is a sample status of running the CDK deploy command post the migration of CloudFormation stacks into CDK enabled code. Please excuse the font size, and this can be viewed in an enlarged mode once the slide deck is available for download for the people who have joined the session. Next is the CDK-def. This is to compare the changes in the AWS account after running the CDK deploy on top of an existing account where initial resources are created via the CloudFormation stacks, and later we deployed the migrated code via CDK on the same infrastructure account. This is a glimpse of a CDK-def command, which is applied to verify the changes made and has an expected effect on the resulting CloudFormation template. Now let us quickly understand how the CDK-def is working behind. CDK tool will be adding a hash calculated value at the end of the logical name inside the templates. So this hash is calculated based on the attributes. So if any attribute changes, CDK will know that it has to compare the changes between the sources. Next comes the CDK Bootstrap. Bootstrap in CDK CLI allows us to map the CDK environment with the AWS environment and region. Basically, it creates a CFN stack in an environment. For example, TypeScript project here. We can also bootstrap one or more AWS environments, and by this way, multiple accounts access or multiple accounts from different environments can be bootstrapped for CDK deployments. So now, post the CDK init and the CDK bootstrap, we can see a cdk.json under the CDK project setup that we have created. Key objectives of a CDK project, the CDK file is that it has the instructions on how to apply or execute the application or the code that we have developed and retained in the CDK project folder. Second one being, it allows us to define which changes of the new features into the CDK code by way of enabling and disabling their usage with a Boolean value setting. Now, people or teams who had already invested in CloudFormation and who have reached a stage in cloud setup will think twice on moving on to CDK. Reason being, the time and effort, design, planning that was invested in CFN creation, implementation, and maintenance has been mastered over a period of time, and adopting to CDK will now be the same kind of journey with different platform and different learnings of its own kind. So in order to eliminate this obvious limitation, AWS CDK has a module named CloudFormation Include. This module contains a set of classes which will aid in getting the CloudFormation templates in CDK. The existing CFN template used should also be tagged along with the CDK project so that the resources created by the CFN are linked or connected to the CDK with all the existing changes applied will be understood by the CDK. Later on, the new changes that are made on top of the CDK code can be used and taken forward after migration. So these are the resources which are created and applying the CDK deploy after the migration. So this is a glimpse of the root tables that are being created. And this one is for both the private and the public subnets. And just that we completed the CDK experience of migrating existing CFN stack to CDK and even witnessed the deploy div status of the same. Now we can go ahead and apply CDK destroy, a simple command which will do the same rollback functionality of whatever resources that were created as part of the CDK, which was earlier created as part of the CFN as well. Now let us see a feature which is so vital and interesting, which by implemented using the same cdk.json for multiple environments within single AWS account or different environment in different AWS accounts. So the good thing about CDK is that with single code base and multiple GitHub structure for each environment, we will be able to orchestrate deployments across environments with customizations against each of the environment with few definitions in cdk.json. We just have to point to the relevant branch or the environment and run the CDK deploy to deploy the current code into the target environment. Customization, for example, would be in case of an EC2 instances creation, going for a spot instances in dev and test, but an on-demand or a reserved instances for prod environment would be a very good example in this case. So this is a sample of how a cdk.json should be looking when we are trying to implement a multi-environment deployment using multiple branches mapped to different AWS environments. By this way, we are achieving a simple implementation of continuous deployment CI/CD in a multi-environment. Now that we have seen the process of migrating existing templates of CloudFormation into CDK, code of TypeScript in this example, we have gained our confidence in making the journey into trying out CDK. To start with, we always follow the well-known AWS documentation, which gives clarity and comprehensive details about a feature, FAQ on the service, or a feature in context. It's good to start with the right background of knowledge, as well as it's good to have a good background and a strong foundation by doing a continuous learning and having continuous effort. Well, to make it more interesting, here comes the interesting spots where you can start looking out for. The case we have seen here for migration might not be the same in other cases. Hence, look out at CDK workshop website of AWS to give a head start. This will get you excited as this lab is a hands-on lab and covers all the basic languages. The next stop would be AWS news and blogs, events on CDK features, and finally, do not miss out joining reInvent every year and online summits where new announcement and new feature will be announced against various services. So this is a good place to keep ourselves up to date. Another main area would be to check up on the AWS CDK samples, which is an open repository for people to understand and utilize the common scenarios implemented with code. So hope this gets you thrilled to start looking into CDK as your next infrastructure as code. Good luck about it. Once again, we thank you all for joining us in today's session, and we encourage you to try migration with a simple use cases as above, or a much simpler ones like creation of an S3 bucket, or a much simpler EBS volume creation CloudFormation template code, and try migrating the same to CDK with the language of your choice. Happy learning for you all. And for more information on the AWS CDK Day and CDK information, please visit the handles that were shared earlier. Thank you so much.
Okay, fantastic. So ran just a few minutes over there with time, but that's okay. We're going to go right into the next speaker. Hello, Danielle. How you doing?
Hey, doing well.
Well, thank you for joining us today. We really appreciate it. You're going to be talking about SAM in the CDK, correct?
Yep.
Fantastic. Well, it is all yours.
All right, we're going live. I'm Danielle Heberling, and this is what I learned going from AWS SAM to the CDK. So just a brief overview of what this talk is going to cover. We're going to start with background, what brought me to using AWS SAM, and then what made me want to do the switch to CDK. Just general first impressions of what it was like getting started with CDK. And then after using CDK for a while, how did I feel about it? So just some quick housekeeping. This talk is not about putting down other frameworks or ways to deploy AWS resources. Overall, I feel like that's not exactly constructive. This is also not meant to be prescriptive advice on how to do things the right way. This is going to be me chatting about my experiences, my opinions, my learnings. And your opinions and experiences might differ from mine. That is definitely okay. And I think that's what makes interacting with the larger community more interesting, because if we all have the same opinion, we're all going to build the same thing, and it's just going to be boring and predictable. So with that said, I invite your polite and engaged feedback after the talk. So let's get started. So I have a kind of windy road into engineering. I started out as a music teacher, and after teaching for a few years, I just realized teaching was not for me. So I quit my job and didn't really know what to do with myself. But the one thing that I did know was I still had to pay my rent. So I needed to find another job. And I took the very first job that I was able to get, which happened to be tech support. And even though I didn't choose tech support, it turned out to be pretty serendipitous of a rabbit hole to get down. It was very interesting to me just because every day was different. Every day, a customer would ask a different question. And a lot of times I didn't know the answer. So I would have to find the answer for them. And along the way, I would learn something new. And one trend that I noticed is that sometimes I couldn't fully answer their question because it involved going into the code base and writing some code to fix the problem. So that's another rabbit hole that I jumped down, wanting to go beyond just writing the ticket and sending it up to the engineer. I wanted to be the person to actually get my hands a little dirty and fix the problem for the customer. So that's what drove me to want to attend a code school. And like many code schools, it was only a few months. It was very, very fast. And we covered full stack JavaScript. And with that said, you can't really fully learn a programming language in a few months. So I learned enough to be dangerous. And along the lines of that, they didn't have a lot of time to cover many extra things beyond programming and JavaScript fundamentals. So when it came time to share a link for our final project, they pointed us towards Heroku, which was very helpful, very quick to get started. And I was able to submit my final project. But that kind of got me curious because my general thought process was, why am I going to spend days, weeks, months, maybe even years, toiling away, coding something and not having a reliable way to share it with people? So that's what piqued my interest in wanting to get more into how can I deploy this? So along the journey, I asked a lot of questions around the tech community, and this thing called DevOps came up quite a bit. And I've learned that DevOps can have many different things to different people. But overall, I think most people can probably agree that it's the overlap and the combination of developers that write the code for the application and the operations people that help the developers to deploy and maintain and keep the uptime of the application. Both are very important. I personally have the belief that we need both. But also along the lines of DevOps, I was looking into, different ways that I could deploy things. And I came across this thing called serverless and tangentially the cloud. And as someone who was new to tech, didn't really know much beyond, the iPhones that I used, general consumer electronics, and what I had learned at code school. Even if you did give me a physical server in my house to, deploy something to, I probably would not have known what to do with it. But the cloud and tangentially serverless opened up a lot of doors for me, because essentially I could just log into a cloud provider of my choice, do a few settings in the console or elsewhere, and it would provision the resources that I needed, and I could widely share my code in a reliable way. And the thing I loved about serverless was the pay-per-use model. So I could build something for like a tiny toy project, and it wouldn't have many hits on it because it was just me testing it out. So I wouldn't get charged that much money. But if I architected it in a good way, I could reuse a lot of those architectures at my day job for a full enterprise application, just because the way that serverless scales out when done right. And along the lines of serverless, I learned about this thing called YAML. Positive aspect of YAML is it's very readable. It's generally mostly plain text. But at the same time, as I was writing my YAML templates to deploy my serverless applications to AWS, I found myself struggling a lot with just making tiny, silly mistakes, like missing some spaces, a colon, sometimes even, just like missing a dash when I wanted a list. And I spent probably more time troubleshooting the silly mistakes in my YAML than I would like to publicly admit. But that's kind of also what got my mind thinking towards, this YAML stuff is important because I need it to provision my resources in AWS that I really want. But at the same time, there's got to be a better way, in my opinion, of how to generate this YAML to deploy my serverless applications. And then came along this company called Stackery. I am geographically based in Portland, Oregon in the United States, and Stackery is no longer a company, but when they were a company, they were based in Portland, Oregon, and that's how we crossed paths. And long story short, I ended up being a software engineer there just because I really loved what they did and wanted to contribute to their mission. And Stackery was a tool to help design, develop, and deliver serverless applications on AWS. And they built on top of AWS SAM. So how I like to think about it with my personal stack at the time, we had CloudFormation at the bottom, which is an AWS managed resource where you can represent your resources that you would like to deploy in YAML templates. It does a lot of other things, but super simplified. On top of CloudFormation, there is AWS SAM, which stands for the Serverless Application Model. And SAM is a superset of CloudFormation. So it sits on top, compatible with CloudFormation. It's extra resources for folks who want to specialize in serverless. And then on top of AWS SAM was Stackery. So Stackery added even more to it. And my favorite thing, going back to not enjoying writing YAML personally, was this drag and drop canvas. Stackery did a lot more than this, but this is my favorite thing. And on the right or left, I'm not sure how this is being mirrored, but there was a resource palette, and you could drag and drop resources into a canvas, and then you could connect them together by drawing a line. And what that did was it automatically generated IAM permissions needed for the resources to work. And another great thing is if you wanted to look under the hood, if you wanted to do something beyond what Stackery allowed, or if you didn't like the defaults, you had full access to the template YAML, which was a SAM template. So through that, I've had a lot of extensive experience with SAM, both through the back door of Stackery and the front door of just using it as a developer. So that was all fine and dandy. My next problem is Stackery was no longer a company. So I had to figure out what to do for my personal deployment of things, aside from going back to CloudFormation or SAM. And that's what drew me towards CDK. A lot of people were talking about it. There was a lot of deserved hype. And being a developer, the aspect of being able to write in a coding language of my choice that CDK supports and having it compile down to CloudFormation was very appealing to me. So I decided to get started with CDK. So first thing is I set up my dev environment. And for contrast, this is what I did at a high level for AWS SAM. Notably, the CLIs had to be globally installed on my machine, which sometimes got a little messy, especially when I started using Linux. But they have fixed it now. But anyway, CDK, because it is, I believe this is why, because it's closely tied to a programming language. I picked TypeScript, being a JavaScript developer. And I really loved that there was an NPM package for it. You can globally install it if you want, but I personally liked just installing it in my project and having it contained there. And yeah, I've already used NPM a lot, so I didn't have to toy around with different settings and things like that, and it was great. So after getting installed, I looked at the docs. And as I mentioned, I was very new to TypeScript. I had worked with typed languages kind of off and on, but not as my primary language. So I was still pretty new to adding types. And looking at this as an example, there's a lot of props and things like that that can be added to the different CDK constructs. And for me at first, this was very overwhelming. But then I quickly learned that the props for a lot of the constructs directly mapped to its brother or sister CloudFormation resource. So at first, I would kind of do what I called cheating by looking at the CloudFormation docs. And then I would use that to inform what to search in the CDK docs. Now I'm very familiar with it, but at the time, that's what I did. And then I learned about CDK constructs. Essentially just the basic building block of a CDK app that represents a cloud component and just encapsulates everything that is needed by CloudFormation to deploy that set of resources. And the first one that was very life-changing for me was this Node.js function one. And the thing that I loved about it was I was very new to TypeScript, and TypeScript has some extra settings in order to compile the TypeScript so it's shippable to be used in applications. And I was still kind of learning how to do the build and things like that. And the thing that I loved is this Node.js function construct just automatically detected that I was using TypeScript, assuming I gave it the right props. And it built my TypeScript for me and packaged it, and it just magically worked. And that was kind of where I realized there's a lot of power to this CDK thing. And it's just a joy to work with. And then I mentioned this before, but the community seems very active and very excited. So that was the next thing that I noticed getting started. This is a picture of the CDK patterns site. Because you're writing code, there's multiple ways to do the same thing. And I really love, sites like this and other resources where people can share the different constructs that they wrote and get inspiration on maybe how to do something. So overall, it was a smile and a thumbs up for me getting started. So let's chat about how I felt after using it for a while. I've been using it for probably about 1.5 years at this point, and I like pros and cons lists. So let's start with the bad news. So cons, I feel like CDK compared to CloudFormation/SAM, it feels a little bit like more maintenance. And the reason why is because when you're writing code, a lot of times you're going to be dealing with code dependencies, different packages maintained by different folks to different levels of good or bad maintenance. And overall, I'm the type of person where I really like to keep things up to date as much as possible, just to ensure that all the proper security patches and etc. are fixed. So that's another step that I needed to do. This one is a little outdated, so I will caveat with that and explain that in a moment. But CDK has, in V1, they have multiple dependency packages that you install. And I found that if they were in a different version, I would often get a lot of errors, specifically type errors, but sometimes other ones that I didn't really understand. But I quickly realized that I just had to pin them all to the same version to make sure to not run into that. But with V2, it seems like that is almost widely fixed. So it's great to see that the folks that maintain CDK have listened to the community and have addressed people's complaints. And then, like anytime you write code, you need to make sure things are compatible. So constructs you write, constructs from someone else that you might be pulling in, make sure they're compatible with your setup. And then finally, I just wanted to mention CloudFormation runs under the hood of CDK. So CDK is, from my experience, has been very easy to get started with. So I feel like sometimes it's tempting to just, copy, paste, deploy, and it just magically works. But then down the line, if you do that, you'll run into some errors that you might not fully know how to handle. So I just wanted to say that, it's important to understand all the underlying infrastructure of what you're deploying. I know for me personally, just experience using it, chatting with other folks, also getting AWS certifications. Not mandatory, but helpful. So pros, go quickly through this. Overall, it just feels faster. I feel like my dev loop and everything is just, I don't have to do that mental context switch between YAML and TypeScript anymore. So for me personally, it just makes things a joy to work with and way faster. So final thoughts, if you would ask me today, do you prefer SAM or CDK? My biased opinion would be CDK. But with that said, anything in tech, it's all about trade-offs. So, what's best for me might not be best for you. If I'm on a team, it might not be best for that team. So at the end of the day, it really depends. But the cool thing is, between CDK and SAM in particular, is that you can use both if you want. Like I hinted at before, knowledge is transferable between the two. So thanks for listening. Hope you have a wonderful day, morning, afternoon, evening, wherever you're at.
All right, great. Well, thank you, Danielle. I really appreciate it. We are going to continue right on into the next talk. Normally, we would have a break right now, but we appreciate you coming in and talking to us today about this whole transition from the SAM to the CDK.
Thanks for having me.
Have a good one. All right. So we normally in our schedule, we have a 10-minute break here for a quiz, but because of the scheduling confusion, that got moved up. We're going to go and jump right into the next talk without much of a break. So let's get rolling. This one is going to be talking about a very interesting project regarding the CDK and writing your code in a web format.
All right. Today we're going to talk about CDK-web, which is CDK compiled to be executed inside a web browser. So what was the problem? Why am I sitting here today talking to you? I'm an AWS security engineer, and I work in a team of other security engineers like myself, and we make a lot of detection lambdas. And a lot of these lambdas go out every week in many accounts that our organization owns. And the logic inside these detection lambdas are written, the actual logic are written by another team, the application logic team, and these are primarily written in Python. So these are Python lambdas. And my team manages the infrastructure that goes around these Python lambdas when they make it to AWS, and the resources that these Python lambdas need in order to, operate safely in cloud. So right off the bat, you can see that there are too many native dependencies here. My team depends on Node.js and likes to manage their infrastructure in CDK and Node.js. And we publish tooling that the other team, the Python team, consumes. And since we are writing in CDK, inherently the Python team on their environment also needs to have Node.js installed alongside Python. And everyone who worked in a corporate environment, they know that this is not trivial. It is really hard to maintain and manage versions of native binaries in corporate environments and environments where security is top priority. Like you end up with situations like you get an isolated machine with Node 12 and there's nothing you can do about it, unfortunately. So it's a problem. So if we would like to reduce the amount of native binaries that we depend on as much as possible. And for anyone who's worked with CDK like that in two different languages, knows that it's also about managing the precise version of CDK across languages, which also causes some interesting issues sometimes. And when we publish our tooling like that, it is really huge in size because node modules, node modules folder gets massive, and even packaging it up still doesn't help, and it still needs to go, through our registry and the proxy issues that causes this slow feedback cycle that we were trying to solve. It's all really painful having all the different native dependencies. So what are some of the workarounds that you might suggest? Hey, why didn't you do this or that? You would suggest that maybe we could abstract the core business logic into lambdas and we automate it somehow. While it's theoretically possible to automate everything and anything, I would like to describe the types of lambdas that we deploy as following a random walk model in their content, as if they can be streamlined, but it's extremely different to predict their model. So we cannot automate them currently. So that's not something we can do right now. You might also suggest, well, why don't you just write everything in JavaScript and Node.js? Why don't you just eliminate Python from your environment like that? Well, I hardly oppose to that opinion, because I'm on the camp that if my developer, if the developer who's consuming my tooling is comfortable writing in Python, I do not want to force them to work in any other language, because I do not want to be forced to work on an environment that I'm not an expert in. So I would like my engineers to work with tools that they're comfortable with. So that's not even a question for us. You might also say, why don't you just package this entire IAC application or the infrastructure application with CDK as a CLI app? That's exactly what we are doing, and the huge package sizes and all the other issues that I just told you about caused us to pursue CDK-web. You might also suggest that we'll just use CDK pipelines. CDK pipelines is really good, but it needs a lot of broad permissions, and in the environment that we currently work in, we are not flexible. Our environment is not flexible enough to use CDK pipeline with its current setup, and too many of these one-off suggestions from different people, and it's just too much. If we wanted to invest on something, we would have liked it to be reusable. So this is a solution that we ended up with. We made CDK go through Webpack, which is a JavaScript bundler, which is what it does is that it grabs every single source file and it just shoves it into a single JavaScript file. We eliminated the use of actual node file system, and we replaced that with memfs, which is a virtual file system completely in memory, and we did that through Webpack because we wanted to execute this inside a browser, and inside a browser you don't have access to a file system. We also, we deploy a lot of Lambdas, so we would have liked to keep that functionality when we wanted to, move to a browser environment. So we replaced sbuild with sbuild wasp package, again through Webpack. And we also replaced Python and pip with Pyodide and micropip in our environment, which these are open source projects. If you haven't heard of them, they are WASM compiled versions of Python and pip. And also we made some minor patches to make the final bundle Safari happy. And at the end, we made the entire thing go through Google's Closure compiler to just make sure that it's optimized to the last character of the file. And then we get CDK-web. And this is a version of CDK that is now, first of all, it's entirely in memory, so it can be executed inside browser. And since it's in memory, doesn't leave any artifacts behind. This is also one of the things that we didn't like about the original CDK in our automation pipeline. As security engineers, we don't like unnecessary artifacts left behind from our toolings, and CDK leaves behind the manifest files. While you can say, okay, just remove the file, or in the automation pipeline do that, we like to eliminate that at a framework level and just don't give it a chance to even make it to the disk. And since this is entirely in memory now, it can be also executed back in Node.js. But we wanted to execute this in a browser environment because we wanted to change our CLI application to a web application and just load it from a URL. That would make our release cycle faster, and also the feedback cycle would improve a lot because our consumers of our application, they don't need to work with the CLI anymore, or download a new version every time we publish a new version. Every time now, if they open their browser, every time they go to the URL that we give them, they just get the latest version of our tool. Just effortless delivery of our tooling to the consumer of our application. I'm sorry. Next, I will show you a demo that I've previously recorded. Okay, for demo, I'm going to show you something that I would like to call a progressive IAC application, or an IAC application or a CDK application that can be executed both in browser and in native environments. For the purposes of this demo, I'm going to use VS Code. And also, it's going to be a React app. And my tool of choice for writing React front ends is just using Razzle. You can, of course, just replicate this in whatever tool that you're comfortable in. I'm going to use Razzle today. While Razzle is doing its thing, I should also tell you that Razzle is structured a lot like Create React App, if you're familiar with that. The only thing that we need to change out of the box is that Razzle does server-side rendering as much as possible and then offloads it to client-side. We don't like that because the whole point of CDK-web is that we would like to be executed in client's environment versus server-side. So we are just going to open up this Razzle app and we're just going to change its structure. So it goes from server-side rendered to a single-page application client-side rendered. And this is fully documented on Razzle's website. I'm not doing anything special today. So this is just a default Razzle app that we get. If we do npm start, this will just open up a React app for us. As you can see, there's a server.js here. We don't like that. We want this server.js removed. We want this index.js removed. And we also need to add a configuration here that is, again, fully documented on Razzle's website. All of these are not my comments. These are the comments from Razzle's documentation website. It has a pretty decent documentation. What we changed is that we just told Razzle that we want a single page application. We don't want it to be server-side rendered first. And then we also modified the Webpack config in Razzle. You have to do this for AWS SDK in your project anyway. You're just adding CDK on top of that. We just modified the Webpack config to let it know that it should not process CDK Web and AWS SDK as input files, because these are pre-compiled minified libraries. They should be loaded once and cached. And this just tells Webpack just that. And again, you do this anyway for your regular projects with AWS SDK and React. You just add CDK on top of that now. And the last thing that we need to do to turn this into a single page application, single page Razzle application, is to add an index.html in the public folder. Just like that. And again, this index.html is fully documented. I'm just copy pasting from Razzle's website. The only thing that I've added here is that I loaded AWS SDK and CDK Web for this entire application before React does its thing. Now, if I save this and if I run this, this won't work because we don't have AWS SDK min.js and CDK web.js in our public folder. To do that, first we need to install CDK Web and AWS SDK. I'm going to do that. And in our package.json, we're going to add a post install step that what it does is that it just copies the artifacts of CDK Web and AWS SDK for us into our public directory that our web server is going to serve. You need to do this for AWS SDK anyway, and now you're just adding CDK on top of it. As you can see, CDK Web is, as a library, is modeled after AWS SDK v2 because I just solely find that very convenient to use. So if I did everything correctly, if I do npm install again, this should run and boom, I get all the files that I need now. So if I do npm start now, I should be greeted with a very simple Razzle React app. And we're going to check that. And that's it. We get a React app. We get basic single page React app that we're going to add CDK to it. It tells you what to do and where to go next in here, and you can just read more into Razzle's documentation and React. And we are are going to modify this page to get rid of these links and this stuff that we don't need. Real quick. We'll call it that. Yep. We're going to change this welcome to Razo to welcome to CDK. And we're going to also print its version here. The version of the CDK that's bundled in CDK-web. For that, I'm going to import that version from CDK-web. Just like that. And if I save it, welcome to CDK 2.24.1, which is the most recent release, I believe, at the time of recording this video. CDK Web repository is just automated on every release of CDK. It goes out with a new version automatically, so you always get the latest one. Okay, so the objective is to build a website that deploys another website, or a website that deploys more website. I know that sounds like the description of a worm, but it's not. Just trust me. It's just, let's take a look at this demo, and then you can decide if it's a worm or not. So just like any other just sane CDK application, we need to make a stack. How do you make a stack? You need to import CDK and extend cdk.stack. We can do that with CDK Web now. CDK Web offers a require that we need to rename here to CDK require, because name conflicts with the node's native require. So then we can use that to just require CDK normally, as you would in Node.js or TypeScript. And then I will go ahead and make a stack, just like, again, you would normally do in CDK. The content of this stack, it's very simple. It's going to be a Lambda hooked up to API gateway with a Lambda integration. So and it's just a couple lines of very, very basic CDK. And I will just copy paste from my notes here. We also need to obviously import the Lambda constructs. As you can see, I just use CDK require, which I imported from the CDK web package, and everything else is just exactly like you would do regular CDK with. So I imported function, runtime, and code, and then REST API and Lambda integration for the front end of my Lambda function. What this construct does, or when you construct this home stack, the idea of it is passed as a part of the body of my Lambda code. So we can kind of like make this dynamic. We can make a UI that asks the person to put their name in, and then we can bake that name inside this Lambda, so it feels like you get a different website every time you deploy, right? Perfect. So we have a CDK stack. Now, how do we go ahead and deploy that? Here, if you go down, our components in React, the UI components are very basic. It's just an image and a text. I would like to go ahead and a bunch of form fields here. I would like to ask the person what their name is, and I would like to also ask their AWS access key ID and secret key, so I can deploy this stack for them inside this application. Disclaimer: you should not do this in production. You should not ask people for AWS credentials in browser. What you should do, and what we do, is to either use Cognito user pools or integrate with SAML endpoints inside browser. There are native ways to do it inside browser. You need to change the way you think. If you're too keen on using just AWS access key and secret keys in browser, that's not the way to do it. Do SAML integration in browser, or do Cognito user pools. Do not do what I'm showing you here. This is for the sake of brevity. Okay, now the disclaimer is out. I'm going to show you this form input that, again, I'm just copy pasting it from my notes. And broke. That's fine. I'm actually just going to copy paste this whole thing here and then save and then explain over that. Okay. So this is what I wanted to paste originally. The thing that I copy pasted have calls to functions that weren't pasted, so it broke. So I had to copy paste the whole thing in. But this is the part that I wanted to paste in. It's a form that I made previously. This is a beautiful form that you're seeing on screen. It asks you for the deployer's name, it asks you for the access key ID and the secret access key, and this is just a log window that you will see. You know, the normal CDK logs that you will see if you were to do it natively, you will now see it in this text box. This is just rudimentary React stuff, just hooking up this button to a function call and all that. It's nothing important. And then again, this is all React stuff. And when my component is rendered, I'm just registering to capture the logs out of CDK and just you know, show it to the user, have some sort of interactivity. What I also like to do is that to change the behavior of this spinning thingy that React gives us to be a little bit more exciting, to react to us deploying to our you know, our stack. I would like that. I would like this to change colors. I would like it to be default grayscale, and if it's a deploying, be blue. If it's errored out, it's red or whatever. Just whatever you want. Just something interactive. Which I just changed the CSS of this file from my notes. It's just I added a bunch of classes, extra classes, and that's it. This is the UI. This is the application. If I were to make this UI an application with native code, it would have probably took me 2 weeks to get to just here. But now with just a couple lines of HTML and CSS, we're here. So what does this do? I'm going to show you what this does. It's that when you click deploy and when you give it the right credentials, it goes ahead and calls this deploy function here, which, as you can probably see, it's similar to a very normal CDK app. You just make an app, make a CDK.app, make a stack, pass the app as its scope, and then use the CDK CLI or the pseudo CLI that CDK Web comes with. This pseudo CLI just packages the CDK, the relevant parts of the CDK CLI's functionality for you. So you can just make a new instance of the pseudo CLI, pass it the credentials and the stack you want to deploy, and just call it deploy. And since in this stack I used a Lambda integration, it automatically adds an output for me. That's super nice. I can see where the URL is. So I just go through my stack outputs and just grab the first one because it's just one and I know it's there. And that's it. Let's see if it works. Fingers crossed. I'm just going to put my credentials here. Again, do not do this in production. Do SAML or talking to user pools. This is for the sake of brevity and this demo. As you can see, our cute little animation is going, and you can see that it's connecting to the account. It's my personal account, and it's deployed. Now I've already deployed this stack once. So you can also see redeploys over the same stack also works. I can just grab this and go here. I do not. That's it. That's the response that we were looking for. I'm sorry, I just caught off guard. I don't usually use Firefox. That's it. So if I want to do something else, like, I don't know, let's say you are the audience, and I want to deploy another stack called audience. I don't know. I can just do that. I can just change the name and just do deploy, and it just goes. And This will take, since this is a completely new stack, will take about 2 minutes to deploy, but you can see it's the same exact experience that you get on native CDK. Now you get it on the web, and you have the same functionality, and you have the access to almost all the same constructs. While this is going, I'm going to just briefly touch on that. If you're going to grab CDK-web and use it in production, some of the constructs might be not working as a result of being dependent on Docker, or having bash scripts, or having other scripts that they spawn during, because in Node you can do child process and execute a shell script and wait for its output. A lot of constructs do that in CDK. Obviously, those constructs do not work out of the box. You need to patch those if you want to use this in production, like we did. When we grabbed the Node.js function construct, we replaced the whole native sbuild with sbuild wasp. When we grabbed the Python one, we replaced it with pyodide and pip. So I guess what I'm trying to say is that if you happen to be using one of the constructs that do depend on native resources, there are some labor involved into getting them to work correctly inside the browser. Again, you need to change the way of your thinking. You're moving from an environment to a stricter environment, if you will, from native access to just browser access. Yeah, it's just something to keep in mind. Stuff don't magically start to work. There has been tons of work put into it to get CDK to this point that you see on the screen right now, that is able to successfully deploy a Lambda behind an API gateway with proxy integrations. So the project is still pretty young, but it's working for us in production. I'm just waiting for this to finish so I can show you the second set of API that we just deployed with the name audience. And if you remember, in the code, we changed the body of this Lambda to have this name inside it. So this one, when it gets deployed, I should get a different message here. It is deployed. Just gonna grab the link. Good. Open a new tab. That's fine. Deployed by audience. And that's it. That is what I wanted to demo today for CDK Web. A website that makes more website, or a progressive IAC application executing IAC changes in your browser. If you are a team who is making CLI applications with CDK, or if you're doing heavy automation with CDK, and you have human elements in between like us, or you just simply wanted to make a cool new React front end for your CDK application, now you can do that with CDK Web. Yeah, that wraps up the demo. Redo. Okay, so now that you watched the demo and you watched a website that can deploy other websites completely in your browser without any server resources, I would like to wrap this talk up. I showed you that, as you saw, CDK Web is a bundled and minified version of CDK designed to be executed inside of a web browser and inherently in Node. CDK Web is entirely in memory. It leaves no artifacts behind. This is really important to people like myself who work in the security domain. We do not like extra artifacts left behind from like IAC applications, which are completely unnecessary. CloudFormation is holding the state for us. That's perfect. That gets the job done for us. CDK Web is also pretty lightweight. The bundle itself is 20-something megabytes. It's like 22 megabytes. And with the optional dependencies, it is still lighter weight than the native CDK. And we found out that in Lambda environments where size matters, we replaced the native CDK with CDK-web for just a little bit of a couple megabytes to save here and there. Also, as you saw, I independently installed AWS SDK. This is very important to people who work with the AWS SDK inside browser, because a lot of places customize their AWS SDK and there's a way to customize it. And currently in native CDK, there's no way to bring in a customized CDK web, AWS CDK, without a lot of patching. But here we just get that out of the box, again, thanks to being in a browser-like environment. And what's next? I would like to keep pushing this terminology, progressive IAC applications. I would like to see, you know, constructs that are both web compatible and native compatible. You know, I would like to see or add interop with native CDK between, you know, CDK web and native CDK. Maybe they can talk to each other. Maybe the parts that needs Docker access, the CDK web can talk to native CDK. I don't know. These are extreme use cases. Like if you are on CDK web, you shouldn't need that. But again, these are just nice to haves. And of course, Projen support. CDK web doesn't have Projen support yet. I'm working on that. And finally, CDK-tf web. If I'm going to use Terraform at some point in the near future, I'm going to also bring CDK-tf to web. And that's about it. That's about wraps up my talk about CDK web. I hope you enjoyed it as much as I did. Thank you. Thank you.
All right, well, there you go. Talking about CDK and how to run it within a web browser. That actually wraps up all of our talks for today. I believe both track 2 and track 3 have also ended, so this is the end of it. I want to say thank you again for everybody who came out and watched us today. We couldn't have done this without you. We wouldn't do this without you. I want to say thank you to all of the speakers who gave presentations today. Again, this would not have happened if you hadn't submitted, and we're grateful for all of you here. Thank you to all of the committee members who helped make this happen. Big special thanks to Western Interpreting Network, who did the ASL translation today, and thank you to AWS for covering those costs for us so that we can continue to keep the CDK Day free for you without a cost for tickets. But that is it. Please, join us on the CDK Dev Slack channel, and otherwise, we will see you next year. Thank you very much.